such as zk-Lite clients. And so let's just look at how powerful warp routes are. I'm going to show you a demo. OWL protocol built a UI for self-deploying a warp route. It takes 60 seconds to do the deployment, and then it just works. You don't need to run any infra. You don't even need a wallet to use OWL protocol because they have account abstraction. And it's pretty much a one-click deploy, and then you can start bridging via Superbridge. It's this one. Yeah, so they have like this website interface where you can select the tokens that you want to connect using the warp routes. And so you get to connect the origin chain. Let me start the demo. You get to select the origin chain and then the token you want to bridge from that chain. In this example, they're going from the Sepolia testnet, bridging native ETH to some destination chain, minting synthetic ETH. On the right-hand side, you just set the token name and symbol for the synthetic. But the warp routes allow you to connect collateral tokens as well, which means you don't need to mint synthetics every single time, like to wrap assets. You can just provide liquidity and allow people to lock and unlock, essentially. And so in this example, the warp route connects 3 chains, native, ETH on Sepolia, and then synthetic on the other 2. The user click deploy, and then the transactions are out on all 3 destination chains. You see the live status there, and you didn't even need a wallet interaction because they're account abstraction. And the really, really cool thing about this is that after the deployment is done, you get a configuration with deployment artifacts of the warp route, which you can then use in the Superbridge app, which is a bridging interface. And you can start bridging straight away. You have a UI with the bridge you just deployed. And you then select your origin chain, the token you want to bridge. And like you're good to go. You have a live token bridge. The only thing remaining to take this to production is to move ownership of these contracts to something very safe because it's currently owned by the hotkey in account abstraction. All right. And so moving on, we've seen how Hyperlane has made token bridging based on messages very, very easy to do. Let's look at what intents are. Hyperlane is building on top of that. An intent is really a user expressing their wish to chain. They do so by sending a transaction on the origin chain. Then there's an off-chain actor called usually a filler that will notice that intent and then perform an action on the destination. Usually this means the user wants to bridge some token from an origin chain to a destination chain. And so because the filler will have balance on the destination, they will send those funds to the user immediately. And then the steps are essentially that. Number 1 is you sign an order that gets sent on chain, on the origin chain. There's a settlement contract that takes the user's tokens into escrow. After tokens are in escrow, the filler can send funds to the user on the destination chain. And then the last step is to reimburse or pay the filler with the tokens that were held in escrow from the user. And so, people who build intents almost behave like, oh, you don't need in order to do cross-chain actions. But the truth is that for settlement purposes, you absolutely need general message passing because the filler needs a way to prove that they sent funds to the user on the destination. And so, general message passing will always be required. And the question is, how can we do that? How can we make that easier? Just found it interesting that over time, clearly intents have gained a lot of popularity. Now they're around 50% of cross-chain volume compared to message-based token bridging. And let's look at some facts about message-based token bridges, which are warp routes, and intents. So warp routes are slow because they need to wait on finality on the origin chain. If you don't wait on finality, a reorg could occur, and so the tokens you sent initially are then given back to you because it's as if that transaction never happened. So you kind of end up double spending because you receive tokens on the destination and you get them back on the origin as well. But they're very easy to bootstrap. Like you've seen the demo, it takes around 60 seconds to deploy. You don't need inventory in order to fill users on the destination chain because in most cases you mint synthetics. And it works between any chains because of that reason. And what's more, execution is guaranteed because you can, even if there's no relayer to send your message to the destination chain, you can relay your own message that will, cause new tokens to be minted. So that's pretty convenient. But then they're slow, right? And that's where intents really shine because the filler, in many cases, doesn't even need to wait on finality. The fee you pay to the filler to do the cross-chain intent execution usually acts as this reorg insurance almost. So basically, on average, or reorgs happen very, very rarely. So it's very safe for fillers to assume that over time the fees they get are greater than any funds that they may lose because of a reorg. So this is the big, big benefit of intents, and it's why they're taking off. But they're much harder to bootstrap because you need fillers, and those fillers need inventory. And they need inventory either in any token that you're trying to bridge cross-chain, or they're going to need to take their, say, funds and then swap them and only them send them to the users. I'm not sure what happened here. There you go. Cool, let's keep going. Yeah, and as I said earlier, we still need general message passing bridges for settlement. But then you also need them to mint inventory. Like if a token doesn't already exist, it cannot be held by the filler, then it's impossible to do intents. And then also, as a filler, if all users go from one chain to the other, bridging is very imbalanced, you may end up no longer having enough funds to fill orders. So you need to rebalance your inventory. And you also need likely like a general or traditional token bridge if there's no other filler to allow you to move your funds. And so as I said, intents today are generally cheaper and faster, so more convenient than token bridging. It gives users a better experience of using the app. But the bad is that intents protocols today, they roll their own messaging protocols and they tightly couple security. So I think a very common use case is to use some sort of optimistic oracle that proves that settlement happened on the destination chain. And then, yeah, because of that, you have these intents protocol that do both intents, but then they also do token bridging. So they're kind of spreading themselves rather thinly. And obviously, they can't do everything best. They should focus on what distinguishes them from their competitors. And as a result, intents are usually limited to a handful of chains. And this is where basically we started thinking about why not use a general message passing protocol to settle intents instead of building your own, so you can focus on the intents layer. And besides that, basically just allowing us or other message passing protocols to handle settlement for you. What Hyperlane really gives you and where it really shines is that it has modular security, which means that different sums can be settled with different security mechanisms. So say there was just a single order of one $1 that you're trying to settle, that doesn't really warrant the highest level of security. You can go with a cheaper method, like maybe some multisig or some trusted oracle that tells the protocol, yes, a dollar was really sent by a filler to this user. You can now pay the filler on the origin chain. So as a protocol, you can have these sort of criteria. And this, in turn, makes it cheaper for fillers to operate because, I guess a less trusted security model will be cheaper to verify. So fillers will have to pay less in fees to use the Intents protocol. And in the end, all this means user get lower fees. Yeah, so kind of like to think about all the stakeholders in an Intents protocol. The protocol itself gets to pick its trade-off that best matches the settlement speed they want to achieve and the security and the cost for different kind of sums that end up being bridged. And you can focus on attracting users, making it easy for solvers to integrate. Then for solvers, again, like you get kind of abstracted from many of the complexities of message passing, and you can focus on what you do best, which is manage your inventory, index new intents so you can fill them quickly, and then including your transactions. And then in terms of users, overall you get better quotes because settlement can happen very dynamically based on the amount being bridged, so it can end up being cheaper. And it's a virtuous cycle because you start off with better UX. This attracts more users, which generates fees and volume, and this leads to more competition, which attracts solvers. And because there's fiercer competition between solvers, you get lower fees, which attracts more users, and so on. And with that in mind, we started developing an open source Intents framework where we already have a solver that's live. We have basically a CLI that you can use to spin it up, contracts that you can deploy where users can send their intents. And actually, I have a demo to show you exactly with that. I'm not sure how good we're at time, but yeah, you just spin up the solver and it indexes the origin chain. It will look for intents as they're being broadcast. And then if the solver has enough balance on the destination, it will fill the user's order, essentially. And we're trying to make this, 7683 compliant. There is no 7683 Intents protocol live in production today. And we're trying to, ideally turn this into an industry standard that other Intents protocols can build on top of and then add their solver and so on. Yeah, so as you can see, the intent was noticed, then the order was filled on the destination chain, and then the final step is settling it, which means the filler gets reimbursed on the origin chain, and then there's some transactions there. And just because we're very short in time, yeah, let's get to the bounties. So you can build anything. The best projects will get the prize out of the 10K pool. If you don't have any ideas, what I can suggest is basically two main areas. One is account abstraction and the other one is intents. In terms of account abstraction, Hyperlane supports interchain accounts where you can control accounts on remote chains from like some origin chain, and you can have balance, you can initiate authenticated cross-chain calls, but like smart wallets today aren't integrated with that. And then, yeah, the other thing you can do is build around intents. So the current framework we built only supports token bridging, but you can have call data-based intents. So basically, cross-chain calls. You can build a request for quote system to have better, pricing discovery of how much it costs to send an intent. In the current version of the framework, users have to kind of estimate or assume how much it will cost. You can also build a UI for this intent system that I just showed you. And yeah, really, I just invite you to come chat to us at the booth for more, because there's tons of things you can build, and it's all open source, which makes it way easier. Yeah, thank you. Yeah. Oh, can they?
Does it require someone else already kind of deployed those new capabilities?
Yeah, anytime. I don't know about that, but good to go? Okay, great. Can you see my screen? Are you able to see my screen?
This one.
Maybe mirror?
Testing. Cool. All right. Hello. I am Greg Devrel at ENS Labs, and today we're going to be talking about ENS as a source of identity in your apps. So, first of all, let's answer the question, what is ENS? The Ethereum name service is a decentralized, permissionless naming protocol that lives on Ethereum and scales to the entire internet. Basically, we turn complex hex addresses into human-readable names. And so up top, you see my address is OX179A and so on. Obviously, nobody's going to remember this. It's hard to understand. It's confusing, and so on. But instead of that, using gregsquirrel.eth is a human-readable name that people can understand, and it's easy to send assets to or represent me kind of on-chain and online. So a common way to understand ENS is similar to DNS. You know, DNS is everywhere. It's in the browsers that we use every day. It maps IP addresses to human-readable names. So instead of typing in an IP address in a browser, you type in google.com. And similarly, for ENS, instead of typing in an address, basically anywhere I use this address, gregsquirrel.eth represents me instead. And so if you can think about anywhere browsers show IP addresses, you should use names. Similarly, anywhere you read or write an you write an address, you should be able to use an ENS name. So on the left, you can see Etherscan, an example of where you would see a list of people sending transactions, and it shows Luke.eth sending something in to gregsquirrel.eth. That is so much easier to understand than something like what's right below it, of me interacting with a smart contract that just has an address, OX554F, and so on. That means nothing to me, but a transfer of Luke.eth into gregsquirrel.eth, very easy to understand, just at first glance. And on the right-hand side, you can see the kind of opposite, right? So not looking at something that happened in the past, but me sending assets to gregsquirrel.eth. I just type in the name, easy to remember, easy to type, and it just works in MetaMask Wallet and in many other apps across the ecosystem. So these two kind of features are different processes, right? We have forward resolution, where typing in a name resolves to an address, and it's actually a specific address on a different chain. So I can store a different address for base than I can for OP mainnet, and so on. And same for reverse resolution. So I go from an address to a name, and this is used in the example of Etherscan that we saw earlier. We call this primary names. And as of basically last week, you can also have a primary name for each L2, whereas previously it was just a primary name on mainnet. And so I will talk a little bit more about that later, but that's just on testnets now. So some exciting new stuff to play around with. Anyways, ENS started as this idea of a username, just a name to an address mapping. But really, over time, it's moved into more of a profile. So this is a view of Luke's profile right here in the back. You can see he has a bunch of text records, we call it, basically accounts and general metadata. He has a list of addresses across chains. This is both EVM and non-EVM, so he has a Bitcoin address right there. And all of this is kind of stored attached to his ENS name, because it's really a portable on-chain profile more than it is just a Web3 username. And so you should be thinking about it from that perspective. Similarly, this is, again, the primary name part. When I sign into apps across the ecosystem, it will show me my name, not only my address, because, again, ENS is my portable on-chain identity. And so why is this important? The kind of goal here is that users of crypto-powered experiences should never interact with hex addresses, because they're confusing and long and just annoying, right? And then we take that a step further and say users of any experiences should never interact with hex address. So it's ENS's goal to solve this. This is the Ethereum logo, as we all know and love. And the ENS logo is actually designed to be a wrapper around Ethereum, because ENS makes Ethereum and crypto at large easier to use. Yeah, it's a nice little detail that I think some people miss. Cool. And so moving on, what are the different types of ENS names? A lot of people just think .eth is ENS, but that's actually not totally true. So ENS is the protocol, but it supports a number of names. .eth is the one and only native TLD. So that's the one basically that we created, and it is on-chain, and it is maximally decentralized and all of that stuff. But ENS also supports DNS TLDs. So google.com, gregscroll.xyz, I think I have that, and so on. These can all be used as an ENS name. And so anywhere you type a name, yeah, question?
Tom, how does that get involved with the...
Yep. So the question, just to repeat for the recording, is how does a DNS name work in ENS compared to a .eth name? And the answer is exactly the same. Anywhere you can use a .eth name, you can also use a DNS name, like a .com, assuming it's like enabled to do so. So it doesn't work out of the box, but there are very easy ways to configure an existing DNS domain to work within ENS. And I'll show you a little bit of a live example of that in a second. But so just to kind of compare those two things, .eth lives on mainnet Ethereum. It is maximally decentralized, kind of our gold tier, let's say, and it's controlled by ENS DAO, and there is a fee to register those names. DNS, on the other hand, there is actually no protocol fee. So that's one way it differs. The only reason there is a fee for .eth is to keep a healthy namespace and avoid people just holding a .eth name forever. That's not a healthy namespace. Whereas DNS names, they already have that. And so because it's considered a safe namespace, you can use it in ENS the same way you can .eth. Ultimately, one big difference, though, is that ownership is controlled by the DNS domain registrar. So Namecheap, GoDaddy, and so on. It is not as decentralized and on-chain native as .eth, if you want to put it that way. And then both of these names support off-chain and L2 subnames, or really, they both support the same stack of flexible data that you can do with ENS. And I'll explain more about this in a second, but subnames are the idea of having sub.name.eth, similar to how you can in the DNS world. And if you do this, again with .eth or DNS, there's no protocol fee. Developers have ultimate flexibility to kind of build what they want. And this is made possible by a spec called CCIP read or ERC 3668, which I'll show you a fun diagram for in a second. But this is used by Coinbase, Uniswap, Linea, and more out in production. You can see here the biggest one is actually cb.id. That's not .eth. That is a DNS name that they imported into ENS for free and gave out 12 million subnames of, also for free. So Coinbase actually gave 12 million users a human-readable blockchain name without paying ENS a single dollar. And that's pretty impactful when you think about it. And the others are similar, but they use a .eth name. So I'll do a quick overview of how ENS works from the tech perspective. The ENS kind of core registry exists on mainnet Ethereum, and it stores a name side by side with a resolver. And again, you'll notice this registry stores both .eth names and DNS names. A resolver is what's responsible for kind of returning the data that is associated with a name. And so here you see Luke.eth has a list of addresses, text records, and so on. These are just stored internal contract storage, which means it is, again, the most decentralized, but also the most expensive because of mainnet gas. I'll give a little shout out to the content hash record over here, which is basically a way to turn a .eth name into a decentralized website. I'm going to kind of skip over that for now, but happy to take a question at the end for more. An off-chain resolver, which is how you do the subnames like I mentioned previously, basically starts with the same data structure, but you just return different results. So instead of using internal contract storage, you actually revert with this off-chain lookup. And this is CCIP read, this standard for reverting with an off-chain lookup. And what that means is it tells the client to basically get data from elsewhere. So if we look at this diagram, the client, let's say, is MetaMask wallet. The resolver is a smart contract on mainnet Ethereum, and the gateway is an API that you have somewhere in your backend. Right? I want to look up example.eth. I ask the resolver what is the ETH address of example.eth, and it reverts with this off-chain lookup that basically tells MetaMask, again in this example, to basically ask the same question to this gateway. And then the gateway will return some data that it gets from an off-chain data source. That off-chain data source can really do anything. It can fetch from a database, it can fetch from a layer 2 network, and it is really implementation specific. So whatever you want to do is possible with this architecture. And then the cool part is that in this callback function, so where you see the verify decode data, it will actually verify the data that the gateway returns. And so this is how we have trustless L2 subnames. In this callback function, for example, you can check that the state that was returned by the gateway on the right-hand side actually exists on layer 1, just depending on the way layer 2 rollups work. So layer 2 rollups occasionally post their state to mainnet Ethereum, and in this little verify callback function, we can check that it's telling the truth. The reasoning for this is that the gateway can never lie, and this is a trustless L2 setup. So an L2 resolver looks like this, which you'll notice is exactly the same as an off-chain resolver, because they both just adhere to CCIP read, and it is really up to implementation-specific logic for how you're doing, where you're reading from. And so, again, the difference between off-chain resolver and L2 resolver is really not too much from the surface. They both use CCIP read. They both read from some off-chain gateway. And it's just the gateway in one scenario on the left reads from off-chain data, like a database, whereas the right-hand side reads data and returns storage proofs from a smart contract on layer 2. And then that verification logic, that last step, is really the difference. The left has arbitrary verification, so you're just trusting the operator of the gateway, where on the right-hand side, you're actually verifying the state root of the layer 2 itself, again, to have trustless L2 subnames on an ENS name, because it is significantly cheaper than on-chain, than like L1 records. Okay, so I know that was a lot, and I will have time for questions in just a few minutes. But first, I want to run you through a couple new resources. So I'm going to have QR codes both on this slide and the next slide, and then the following slide as well will be kind of like one QR code that goes to a doc that has all these other ones. So if you miss these first two, it's okay. But I want to take a second to highlight this new tool to issue L2 subnames, and we're calling it Durin. Can you see that? Yes, you can. Okay, so Durin is basically an opinionated approach to building L2 subnames with ENS. This is what makes the cb.id and the linea.eth and the base.eth stuff possible. This has been possible for a while, but just a lot of moving pieces and honestly quite difficult. So exactly for this audience, for hackathon developers that want to quickly build something really like interesting on ENS, we came up with this. And the idea, I'll pull up the GitHub README to kind of go through a quick overview. But this is basically, yeah, an opinionated way to do L2 subnames. It makes it super easy. It gives you one contract that you can customize and deploy to a number of layer 2s. And then all of a sudden, you have a layer 2 smart contract where you can register names like sub.name.eth, and that will work anywhere your ENS names work normally. And so again, you'll have another opportunity to copy this QR code, or the domain durin.dev is just a really easy approach. And so this is a brand new thing. It literally launched a few hours ago. So if you have any issues with it, or if you have any questions, this is what we want to see people building with the most. And we will be by the booth in the back, obviously helping people with it. So that's the latest tooling for L2 subnames. And then we have L2 primary names. As I mentioned at the beginning, primary names is kind of the second process in ENS, and what really turns it from an address, or sorry, from a Web3 username into a Web3 profile. Primary name is like anywhere you see an address online, on Etherscan, on a dashboard, anything like that, you should be able to basically turn it into a name. And that process of an address kind of declaring that they want to be known as a certain name, currently on mainnet is only possible on layer 1. And so again, high gas fees. But as of this week, the contracts to do that on layer 2 are now live. And so if I go back to this page, it has information on how you can do exactly that. And so docs.ens.domains will have information on a whole bunch of stuff, including this. But basically, the idea is with Durin, you can create L2 subnames for super cheap, and then you can set the primary name for that account on whichever given chain that you're using via the L2 primary name kind of new feature. And this provides an L2 native experience for your users, and also easier for app developers because you don't have to handle every step of the process thanks to Durin like you would have had to. So the combination of these two tools is kind of what we're looking for this weekend, and the main prize, which I will talk about in a second. But I'm just going to leave this screen up here for a second because this has a link to a Notion page that includes basically quick start guides, snippets, contact info, etc. on all of the stuff that I just discussed. And it looks like a couple of people are still scanning, so I'll keep this up here for another second. Cool. And then these are our prizes. So based on everything that I just explained, the three things that we're looking for the most, or really the two things, are best L2 subname experience that is built with Durin and uses L2 primary names. This could be naming smart contracts. This could be onboarding a new user through some consumer application, and setting their primary name right away. And kind of anything else that you might come up with. We think this will be the most popular way to implement ENS going forward. And so this hackathon is really the first place that we're going to see people use it. So very excited about that. The second that I forgot to update the emoji for is about most creative use case of ENS. So obviously a lot of people are into AI and agents right now. If you're building AI agents, maybe you can think about naming that with an ENS name. And so, for example, if you're using XMTP or some messaging protocol, you can go to message agent.eth effectively and get certain functionality, whereas a different agent would have a different name. This can also use Durin if you wanted to. So it's just like creative use case plus L2 primary name, or just a creative use case on your own that could be unrelated. Another example here is something privacy related that we'll kind of leave up to you, but have some ideas if you want to come by the booth and ask questions. And then lastly is best use of ENS. This is likely to be an L2 experience. So there will probably be two winners of the first prize and the last prize, both being L2. But generally, any ENS implementation is eligible to win best use of ENS. Excuse me. And these prizes will total $10,000. So again, that is what I have for you. We have 3 or 4 minutes for questions, I think. But this is the same QR code that was on the previous page, so I'll just leave it up here for a minute as I take some questions. But yeah, thank you for coming. Yeah. Can you say that again?
For example, we have a domain DNS name TLD, .com something. Does it play nice with the during or the primary names? Do we change the resolver in?
Yep. So basically, L2 primary names work with any type of ENS name. That can be .eth on mainnet. That can be .eth on layer 2. That can be .com. Really anything. Yeah.
Is there any plan to make any name that is not a subname also configurable through an L2?
Yes. We actually just announced this week that ENS will be launching a chain called NameChain. That is not really ready to be hacked on quite yet. So in the future, yes, but for the sake of the hackathon, no.
Thank you.
Yep.
I have a question about during there. I used CCIP tools with Off-chain solver before. What is the difference between Off-chain solver and this?
Yep. So the question is, what's the difference between CCIP.tools,
Yes,
which is
yes,
another
yes.
tool that we have, and Durin? Basically, CCIP tools is built for totally off-chain kind of setups, which means reading data from a database or something like that, and it has like signature verification. So it's just trusting that the operator of the gateway is returning the results that it wants to. Whereas Durin takes a different approach, and instead of reading from an off-chain database, it reads from a smart contract on layer 2. And so if I go over here, you'll see in the Durin repo, which is linked from durin.dev, there are a few smart contracts. And the one that you're actually going to be reading from and customizing is this. And so you basically see a register function. It stores that register function in this registry. And when I go to resolve a name, like let's say name.durin.dev, because you can have L2 subnames under a DNS name, then you would end up basically reading from this layer 2 smart contract. So TLDR, the difference is CCIP.tools is built for off-chain data sources like a database, whereas Durin.dev is built for L2 stuff. But cool, I hope that answered your questions. I think we are out of time. If you have anything else, we are at the booth by the stage in the back corner. So hope to see you there.
Sound is fine.
Okay, you guys.
Forcing your cells like a quick charge battery. How do you feel?
Different.
There is a sound problem with the video.
Okay, it's fine then.
You can go to PPT.
Yeah. You can start? Yeah, I can start. You don't want sound, right? The outside is okay. So you want me to stand over there? So it's fine. I can stand. I'll be seeing on this side.
It's okay, I can use my keyboard here. Can you pan the camera a little bit on right side?
Yes.
The mic is on.
I think so. Hello? Hello, hackers. I'm Anil. I work at Rome Protocol. I'll be talking about our project, what we do, Gmain, first of all. So we'll start with a little introduction. You want to play the video first?
Yeah, no.
Sure. Go ahead, play. So we'll talk about getting started with the Rome protocol. So Rome protocol, you can get your L2, EVM L2, getting started on Solana in few minutes, which enables you to use Solana speed and decentralization within few minutes.
Okay, you guys, I'm here. You got my location? You good? You don't need to, like, stretch or something? No, I'm good. I'm good.
Let's take this tachyon enhancer out for a test drive.
Ooh, yeah. I feel that.
That is the tachyon device powering up the speed force in your cells like a quick charge battery. How do you feel?
Different.
Let's see how long it takes you to get back here. On my count. 3, 2, 1, go. Dang, this thing got you cruising.
How fast does he normally go? Not this fast.
Not even close. Are his vitals okay?
Yeah, they're perfect. Cool. It's like having a pit stop attached to your chest.
Guys, I can go faster.
Do it.
I'm back. How long was I gone?
Let's put it this way. You just annihilated your old record.
Yeah, you went 4 times faster than you have ever been.
4 times? That's as fast as Zoom. Well, faster, actually.
So with Rome, you are able to start L2, which brings speed of Solana to Ethereum dApps. You can get started with your L2 within 5 minutes. In the front end, it uses OP-Get Go client. And on the back end, it has Solana's consensus. And you get composability, atomic composability with Solana, and atomic composability with other L2s that are using Rome stack. Second stream is interrops, where you are able to build interop application, which is basically using our SDK. You can compose transaction, atomic transaction, EVM transaction, and Solana transaction as a part of a single transaction. What it allows you to build trustless application that does 2 transactions on 2 different chains at the same time. If a transaction on one chain fails, that means the transaction on another chain as well fails. So it would help bring trustless cross-chain transaction possible and open up a bigger space for application building. Third track is deploying EVM smart contract on Solana, and this allows ability to access Solana's liquidity, ability to access Solana dApp natively via your MetaMask wallet. You can also, we are also working on to access EVM dApp via Solana wallet. So Solana dev community would be able to access EVM dApp deployed using Rome EVM or Rome L2s on Solana. These are the 3 different tracks. So I'll talk about some ideas for builders. The first one is deploying app-specific L2s. So currently you can deploy using OP-Get based client, and it allows you to basically provide, like I talked earlier, composability with Solana transactions, composability with other L2s. So that is a first track, coming up with the ideas that brings app-specific, that helps bring Solana closer to EVM dApps. So you have a big community, Ethereum community, a big code base that Ethereum has or EVM has for dApp. So bring those dApp, create new application, chain application, app-specific chain, and deploy them on Solana to bring interop application to that are not possible before. This second type of application are interop application, which is basically you have a different app-specific chain, L2s that are deployed on Solana. You have native Solana dApps, native Solana application, and bringing and combining the transaction from these different dApps, whether it is from L2, whether it is from the Solana native, and creating these applications. So what are some examples of these applications? So we can think of it, one example would be arbitrage. Say you have a price difference for ETH token or a SOL token on L2 versus Solana. So you are able to pack these transactions, L2 transaction and Solana transaction, into a single transaction and submit, and that would be executed as an atomic transaction. So only cost that you have is the transaction cost, because your transaction, either both of them will execute at once or none of them will execute. So cross-chain lending. So if you are doing a lending on a particular app chain, your assets are on a particular app chain, and the lending for the money is happening on, let's say, on Solana or a different L2. So you are able to compose these transaction as an atomic transaction. So you do not have to lock user asset. You do not have to forego the opportunity if somebody else wanted to buy that asset. So you are able to do this atomically without having to lock and trust some third party in terms of executing your transaction, because all these transactions are happening in a single transaction. So this helps with UX, user experience. So user experience would be that they are not locking their assets and then getting the payment. It is all happening in a single transaction. You can also, when you're doing cross-sale or cross-chain RWAs, sale of tokens, you can drop KYC token, you can have your payment chain and your asset chain transaction. All three transactions in a single transaction, which basically binds these three transactions in a single atomic transaction on Solana, which again brings a better user experience and a better trustless transaction execution. So these are some of the ways in which interop application can be built. Another example, another idea would be to be able to deploy a dApp on an L2 which interacts natively with an SPL token on Solana and able to access its liquidity, able to buy SPL token on Solana. So allowing EVM user using MetaMask to be able to interact with Solana liquidity, able to buy Solana token without having to create a Solana wallet or fund the Solana account. So that is another use case for EVM user to basically, or for EVM developer to build an application that allows you to buy assets on Solana without having to join the Solana chain. And it remains on chain, it remains on L2. So it is different from a chain abstraction where you have Web 2 credential for which the wallet is created. Because in this case, you have an Ethereum compatible wallet which you are using to buy Solana assets. So similarly, you can create application that allows a Solana. I know this is an EVM community, it's an EVM dev community, but you can use Solana wallet to buy assets on EVM. So you have Uniswap where your tokens are, so you can interact with the liquidity pool and buy token using your Solana wallet. So creating this cross-chain transaction possible, whether you are buying using MetaMask or EVM wallet, buying on Solana, or using Solana wallet and buying on EVM. So these are some of the use cases that I think very powerful use cases that we have built this chain, this stack, ROM stack for. So I think these are some of the ideas, and we are also looking at let me talk about the prices. So prize pool is basically we have $10,000 in prizes, and first prize 3,000, and you can see different prize pool that is available for hackers. And so we just launched our testnet a few days ago. So you can start your L2. You are able to deploy your EVM dApp. You can use ROM SDK to create atomic transaction between Solana and L2. So all these three tracks are available for development. You can use your own Mac or Windows or Ubuntu machine to set up the L2. Or you can set up on EC2 if you like much more high performance. there are a number of L2s that are already set up for use. So if you just want to deploy a certain dApp on different L2s and then provide atomic transaction between these different L2s, so you are able to do that. So there are a number of things that are already deployed, so which you can take use in terms of building your application. We have, you can scan this code and it would take you to some of the tech stack, the documentation, the website, and a way to get help, interact with developers in real time. If you have any question, if you have any problems, you need something, so you'll be able to interact with developers in real time. And I'll open up for questions if you have any questions.
Thank you. Yeah, about an idea that you said about arbitrage opportunities, I'm just not really familiar about kind of Solana consensus mechanisms and about like the block creation. Is it like really different from an EVM like Ethereum chain? I mean, is it like between minutes or?
Sorry, I didn't get your question.
Yeah, about you said about a project regarding arbitrage opportunities. So let's say that you have like a price that is different on Solana than in Ethereum, and I want to take advantage of that. And I'm just not really familiar about like the block creation. Like, how do you manage that? Is it like you have to wait maybe the block creation on that is created on Solana to execute the transactions? I mean, yeah.
Yes. So basically, what happens? You have an EVM-based L2 that is deployed on Solana. You have all the liquidity, your Uniswap smart contract running on that EVM, and you have liquidity in native Solana dApps. So when you are creating transaction, you are creating two transactions. One for the EVM, which is basically signing with your MetaMask wallet and creating that transaction. And then the second transaction is your Solana native transaction that you're signing with Solana key. And then you pack that. So SDK provide ability for you to take these two transactions, pack them as a single Solana transaction, and submit to Solana. And these instructions, these EVM instructions and Solana instructions, they are all executed as part of a single Solana transaction. So if any of these instruction fails, the whole transaction would fail, or they are going to execute everything EVM transaction as well as Solana transaction. And you are able to do that for multiple EVM transaction and multiple Solana transactions. So it is not limited to one EVM and one Solana. So any number of transaction you are able to pack and then submit to Solana. So all the transaction would either execute or none of them will execute. All right, thank you very much. If no more question.
We'll take this one. Should be one here. It doesn't matter the number. The number doesn't matter.
Hello. Okay. Yeah, I turned it on. Yeah, it's working well. Okay, I guess we'll kick it off. Yeah, I don't know if you guys are going to be hopefully hacking with us today, but I thought we'd go through some of the docs and just some basic things to get you going. Don't have a lot of time to delve into a lot of the details, so find us after and we can help. But for the most part, essential is a declarative blockchain. The idea with the declarative model is that instead of proposing or submitting transactions to the blockchain that specify how the contracts should execute certain algorithms to update the state imperatively. You're going about this the other way around, where you're basically submitting solutions that tell you what the next state should be. So, for example, what your balances should be at the end of a particular block or at the end of a particular solution submission. And the job of the validators using the contracts is to make sure that that final state is allowed. That final state is possible given certain constraints. So basically a contract is just a collection of constraints, and those constraints make sure that the state is not being updated in random ways. The constraints restrict the state updates to a specific space of some sorts, and what you're going to end up with is every section of the contract will allow you to update the state in a way to achieve a certain task. For example, whether it be the transfer from one account to another, or be it a minting of a token in a token contract, and so on. So I encourage you guys to go through the docs first. There's lots of information here about all the declarative versus the imperative concepts, how declarative chains, or specifically our chain, differs from imperative blockchain, as well as the difference between declarative and imperative programming. Yeah, you might be familiar with imperative programming from languages like Solidity and so on. And then there's a bunch of stuff about the protocol itself, which you might find interesting. And probably the most important place to start actually getting things going is with the Getting Started guide, which if you go to in here, basically has an application, an example application, which is the counter, the canonical counter, which increments by one every time you submit a new solution. And so you should probably walk through this line by line and get it going. It basically describes how to start a new project, how to compile it, what the output artifacts are, and then lets you interact with the contract using a Rust front end. A lot of we currently only have a way to interact with contracts using Rust. If you want to build a full application, you can probably build something in TypeScript. That's going to be a little more involved. But a lot of the infrastructure we uses Rust. And so this Getting Started guide goes through how to build a Rust front end and a bunch of Rust tests if you want to test your application. And eventually, there's some form of a CLI that also provides some examples of how to do a lot of that in the command line, and then end up with a way to interact with our deployed DevNet as well. So with the counter example, I think it might be interesting to go through just quickly, just a final form of a contract that increments a counter is this one, which, as you may see, we have our storage, which is the counter, and we have a predicate, which is kind of similar to a contract method, but it's not exactly called, and it's this whole thing where you're actually solving the predicates, which you can solve multiple predicates at the same time. So there's no call, there's no control flow. You just have this object here that has a bunch of constraints, in this case, just one, that tells you how the counter is allowed to be changed. And in this case, the counter, counter prime, which is our notation for the next state, we're saying is the counter prime has to be equals to counter plus 1. As you see, this is kind of a Boolean expression. And nowhere in here do we actually change the state manually. There is no manual state update in the contract. It's all done by providing, like the solution will propose a new value for the counter, and then the validators will check whether this is valid or not by plugging in the new value, plugging in the old value, and then checking if the constraint is true or not. And that will happen for every constraint, and that will happen in parallel. So that's kind of the idea behind the whole thing. Is smart contracts are basically gatekeepers. They're just there to check whether the state you want, whether your future, whether your desires can be possible or not, whether if the contract allows you to go from point A to point B, then it will happen. And if you're doing something wild and that's just not possible, then the contract will not allow you to do that because at least one of the constraints will fail. So for the most part, you can probably build anything you want. Whatever can be built on imperative chains like Ethereum, you can probably do here as well, or you should be able to. But we think this also opens up avenues for other applications to be built in hopefully a simpler and more efficient ways. And I know in the previous hackathon, some people built a limit order book, and that was fairly easy to do, which was nice, which probably can't be said about other ecosystems. So once you go through the Getting Started guide, there's a bunch of videos I think we'll link to in, if you go to the price page. There's a video here that has more information. It kind of walks through the token contract, or at least parts of it, which you might find helpful. And if you want to venture to this repository called Essential Integration, which I linked to in the Telegram group, and we can link to in Discord as well. That's a very important repository. Under apps, you'll find the counter, the full counter example, with multiple implementation of the front end, but also the token example, which is really important. A lot of applications will probably want to use this token. And potentially, it will inspire you to implement things in maybe different ways. So the token example, if you go to the pint/token source contract.pnt, this is the Pint code that describes the token functionality. And you'll get used to a lot of this stuff. There's a lot of boilerplate stuff in here. But effectively, the core logic of many of these predicates is the invariant you think of when you think about a transfer or a burn or a mint. For example, when you think about a transfer, the invariant is you want one balance to go down by an X amount and one balance to go up by an X amount. And so you encode that in some constraints. For a mint, you're saying you want to create tokens and then send them to a certain account. So there's an invariant for that that says the balance of that particular account has to go up by some amount. And then I have to increase and then the total supply has to be moved by the same amount, and so on. So all of these invariants are constraints. They're not actions. You're not saying there, I want to change. There is no assignment. Like you're used to saying, the value of X must be assigned to or must become this. we don't have assign. There is no assign operator in this language. It's all constraints. It's all Boolean expressions. So everything here, as you can see, is temporaries and just constraints. And every constraint takes a Boolean expression that says what the invariant is to accomplish a certain action. And so you can think about, if you're designing a DeFi protocol of some sorts, all you have to do is think about what the math is, what are the invariants that take you from state A to state B, and then you plug those into constraints in your contract. You don't have to think too much about how to get there. If you need some form of algorithmic computation to actually get there, then hopefully that gets done off-chain. So the point is, a lot of that complex heavy lifting should be done in your front end. So yeah, I would encourage you to really read the token contract and then go back to token and then go to the app. Under source, you'll find a front-end implementation in Rust that allows you to interact with the contract. And then there's a bunch of tests that also show you that, use the front end and show you how to create a wallet, how to sign, how to do all the authentication stuff, how to, invoke methods from the front end to submit solutions to the contracts, to change the state. Yeah. If you can digest everything in this particular application, you'll probably be ready to build anything you want. So yeah, I will probably stop here. We have 5 more minutes. If you have any questions or if you have, we can talk about questions now or after. Yeah.
So if you want to build like something like an MM,
yeah.
And so essentially you will need math to calculate, I don't know, whatever tokens you're gonna get on the other side. How does that work? Does the off-chain computation does everything and sends the end desired results, and then the constraints actually check the.
Exactly, that's the whole point of this whole thing.
Oh, so
yeah.
all the algorithmic computation is off-chain, and then you just make sure whatever you're sending to the contract, it is a valid output?
Yeah, if the constraints allow it, if the constraints are satisfied with that final solution, then you're good. Then the builder will build that solution, will include in the next block, the validators will validate it, everything will be happy.
I see.
Then the state will be committed. And if one of the constraints fail, then it's just going to get rejected. Yeah, that's literally the whole point of this approach, is just move the, there's many objectives to this, but one of the benefits is that we're moving that complex stuff off-chain. Because if you think about it, what a database is, or what a blockchain is, it's a database where all you care about is updating state from one
It's a state machine.
It's a state machine. And so having, doing everything and anything on-chain is kind of a weird. It's obviously useful in some cases, but it's not really the point of a blockchain in most cases, for most applications. And I know a lot of Solidity applications try to do this in an indirect way where, let's move as much stuff off-chain and try to keep the contracts somewhat only caring about start and final state. But in here, it's all done at the protocol level. Everything is made for that purpose. So yeah. We'll talk about this more. I'll be here for the next 2 days, and there's a lot of my colleagues who can talk to you about that stuff as well. All right. Thank you.
Hello, hello. All right, cool. We can get started. Hey, I go by Sauce. I'm the protocol engineer at the Uniswap Foundation. I've worked quite extensively on like the core code base of Uniswap v4, and today's talk is really just like kind of like an intro, but also just me just spewing some fun and random ideas around Uniswap v4. So this is me on Twitter. I'm also known to be like this like shit poster on the GitHub. So if you have ever crawled the pull requests, there's some funny stuff in there. Okay, quickly. So v4 is more than just hooks. It's kind of like a big feature in v4. But we have a singleton design. So what that means is it's a single contract where all the tokens are sort of held and custodied by the single contract versus like the v3 design. This is a lot more gas efficient. And because of this singleton design, we have this thing called flash accounting, or some people also call it like deferred balance accounting. And the idea is like you can stack a bunch of operations that create like credits or debits. And at the very end of the transaction, you do that final token settlement. Whereas normally, like if you were to swap and then add liquidity, you would have to swap, do token transfers, and then add liquidity, another set of token transfers. But with flash accounting, that all just kind of happens at the very end. ERC 6909, it's essentially a wrapper for ERC20s. It allows you to keep your ERC20s within the core contract and allows you to efficiently trade value back and forth. So it's really useful for like MEV bots or like high frequency traders. Another feature is native ETH. So in V2 and V3, you have to wrap your Ether in order to trade ETH. But in V4, we also directly support the native ETH token. Also, again, for gas efficiency. There's this new thing in V4 called donations. And it's related to liquidity provision, where you can kind of donate revenue to in-range LPs. It's a mechanism possibly for like value redistribution. So that's another interesting aspect of v4. And then the last thing with v4 is like there are no fee tiers. You can have all sorts of different fees, like 4 basis points, 22 basis points. And then another area that we see developers engage with is really dynamic fees. This allows developers to freely express and change the fee up or down. There's obviously limits to it, but again, it's not hard-coded by the protocol at all. I think there's some other AMMs out there where they support dynamic fees, but they have like some hard-coded formula to it. But in v4, it's all set by the developer. And then lastly, hooks, which is kind of like the majority of our talk today. So what are hooks? Hooks are a way to arbitrarily attach valid solidity in the swap lifecycle. The swap lifecycle is more than just swapping, right? It's like the whole end-to-end process. So like whenever a pool gets created, like you could check and verify certain things, or after a pool gets created, you can kind of configure it. During liquidity provisioning and liquidity modification, you can also run logic such as, checks or modifications. Whoops. Why does this not? Okay, cool. Sorry. And then, of course, you have swapping. So before a swap happens, you could update the dynamic fee. You can modify liquidity to concentrate liquidity. And then after a swap happens, you could write storage for an oracle. And then also, as I mentioned in donate, I haven't seen a lot of hooks around donate, so that is also another interesting area to explore. And so this is what hooks kind of look like. It's what you would expect. So before a swap happens, it does this check to see if the pool is configured for it. If before swap does exist, it makes this external call to your hook contract. So where it pulls off to the right, that's a totally separate contract that you would implement, and then it returns back to the core contract to run the swap logic. This is what the code looks like. I'll do kind of a deeper dive, but again, like a hook is really a deployed contract that adheres to a certain interface where you can then add some logic to the swap lifecycle. And then quickly, like it's worthwhile to explain the difference between hooks and pools. A hook is a pool, but a pool is not always a hook, is the way to describe it. And so what I mean by that is like pools are simply independent, unique sets of liquidity positions. It's a collection of two assets to trade against, right? Pools have at most one hook contract. A hook contract implements multiple hook functions. And for these hook functions, like before swap and after swap, you can mix and match and choose as you want. If you use before swap, you're not excluded from using after swap. You can, you could use all of them, you could use one of them. It's totally fair game. And just to highlight where hooks and pools are related to each other. So this is the initialize function. So if you're creating a pool, you specify the pool key and its starting price. The pool key, which again uniquely identifies a set of liquidity positions, is defined by its trading pair, so the two currencies, its fees, some configuration parameter called tick spacing, and then as you can see, like hooks. So every pool has at most one hook contract. And then so just diving a little into like before swap and how hooks work. It's kind of what their name implies. Before swap gets executed, before swap happens, after swap gets called after a swap happens. It's worth noting here that in before swap and in after swap, you get access to the pool key. And so within before swap, you have knowledge on like what trading pair you're working on, the direction of the trade, and like the size of the trade as well. And so you can, in theory, design one hook contract that services like ETH USDC, ETH Tether, ETH BTC. So like one hook contract can service and facilitate, different trading pairs. Another interesting data that's passed to after swap is like the swap result. So you get access to the input amount as well as the output amount. And so if you wanted to do like oracles or like maybe different like value redistribution mechanics, you would have access to like the volume. Same thing is true for liquidity hooks. It's split into 4 different functions here. But again, sort of as their name implies, it's logic you can execute during the liquidity lifecycle. Now on to like the fun random ideas that I have around hooks. So obviously, as I mentioned, we have like dynamic fees, and there are ways that hooks can actually charge external fees. We call them like hook fees. And so there are ways to do value redistribution or different sort of incentive schemes for incentivizing either swappers or liquidity providers. There's a whole body of research from Dan Robinson. And so there are some ideas around building like an AMM that's resistant to sandwich attacks. And these slides are a little bit old, but I think like 2 weeks ago, Dan Robinson like had a paper on prediction markets, and like he essentially came up with this like really fun custom curve that would be very, very conducive to like providing liquidity on prediction markets. Man, why is it doing that? Whatever, I'm just gonna roll with it. There are some things you can do with automated liquidity management, as I said. So like maybe in before swap, if you observe like a large trade size, you can like concentrate liquidity. With V4, like we can directly support rebasing tokens, not natively, but like you can roll a hook to support like it would do automated wrapping. So for like Lido staked Ether in before swap, let's wrap it into wrap staked Ether. You could also design custom curves for different asset classes and like rebasing tokens, and that's sort of like the 2 big areas. And the two big themes that the foundation is super excited about related to hooks is like one, something that like improves LP profitability, so around like fee optimization or liquidity management. And then the other side of the things that we're interested in are like hooks specifically designed for certain asset classes and asset types. Another big research area is application controlled execution. I think people also call it app specific sequencing or ASS. And this is kind of like related to, again, Dan Robinson, where like in a hook you can, in theory, like control the order of transactions that are being fulfilled. And so you could maybe order the transactions based on some auction or some sort of fee. And then, so that's for hooks. And then for V4 more generically, because our prizes are not just hooks, but also it includes V4. There's liquidity mining with subscribers. This is like a new feature that's a little bit different than V3. Maybe something around like creating oracles for liquidity positions. Those don't really exist yet, and that's kind of like a cool, fun project. Like I said, with these like 6909 tokens that are like minted by the core contracts, maybe like building some sort of like staking mechanism for these would also be pretty neat. Developer tooling, of course, is always like a very fun topic. This could be anything from like testing kits, I think, and like back testing, like LP performance, just anything to like really streamline and like supercharge like the hook building experience. Are some, you know, really, really great ideas to build in V4. Another area is like indexing as well, like maybe setting up a ponder schema would be really cool for us. And then, yeah, so lastly, I guess just to go into our like prizes. So our biggest prize is hooks. If you just implement a hook that, you know, has a dynamic fee or a custom curve, or, you know, some sort of like fun like value redistribution thing, like, you know, anti-just-in-time. And then our second category is around integrations, kind of like anything where you might be using V4 as a dependency for your project, but you're not directly building a hook is totally eligible. And then our last category is obviously for Unichain. It's just, you know, build some fun DeFi app on Unichain. And that's me on, that's me on Twitter and Telegram, so you can reach me there. We are super active on the Discord. We have docs. If you are interested in building a hook, I recommend our V4 template. It, you know, sets up the dependencies, gives you a boilerplate hook. The tests are all set up. So that's a really, really nice place to start. And then, yeah, I can open up the floor for any questions. So his question was, for the Uniswap front end, if you want to swap through a hook, do you call the hook directly or a contract? That's a good question. You could call the hook directly. It's not like a very common pattern. The hooks are sort of like abstracted away such that like, in theory, like if I wrote a swap router or Uniswap Labs has a swap router and they sort of specify that the trade should go through your pool, it will automatically like execute your hook logic for you. But you could, in theory, design your hook in a way. So the question was, if for the hackathon you make your own hook, do you have to roll your own swap router? No, you don't have to. We have universal router, and I believe I will be merging documentation on it. And then there's a like really, really simple test router that's included in V4 template, and it has like an example for how to use it. And that's good for like a single pool trade. Like you can like directly just trade on your hook.
Just a really simple one. Just because I've never done it before. Just wondering, how do you connect a hook to like a pool? Is it you just need to like register the hook? Like the address of the hook? Is it a separate contract?
Yeah. So registering a hook. So whenever you create a pool, you specify your pool key here. And then inside the pool key, you have iHooks, which is, it's an address. So whenever you create a pool, you specify the hook address.
So you like deploy the pool manager by itself, and then in that you register pools. Is that how it works?
Yeah, correct. Yeah. So before you create a hooked pool, you have to deploy your hook address. It's an entirely separate contract. And then, so you register it on the core pool manager. Like this is the core contract. And as part of like registering or creating this pool, you specify the hook address.
Cool, thanks.
Cool.
So, general question, like if we all here build a hook for a pool, we all create separate pools, maybe for the same pair. How does the liquidity doesn't segregate? Like,
Yeah, I get this question a lot. So, yeah, in theory, a trading pair ETH USDC will exist as a lot of pools. I think there's generally market forces that, you know, where liquidity providers will naturally sort of congregate around like the best performing pools, like the pools that get the most volume. In general, it's a problem that does exist. We don't expect it to materially exist. I've sort of recommended developers that if you are trying to compete on ETH USDC, you might have a bad time. But essentially, like one of our categories, right, is like designing pools and tokens together, right? Hooks and pools, or hooks and tokens together. And so, like, if your token is only predominantly traded on this one specific hooked pool, then you'll get like most of the volume and most of the order flow.
thank you.
I think there was a question in the back, the gentleman.
Thank you. Am I right? So there is no way to remove already existed pool or add to existing pool some hooks?
Yeah, there's no way to remove a pool after it gets created. I mean, I guess if there's no liquidity there, then it's technically like removed. If you initialize a pool, there's no way to attach a hook afterwards. It's like at initialization that the pool and the hook are coupled together. Cool. If there were no other questions, I will be hanging out at the booth. So yeah, come and find me.
You need it? No.
I'm not using. Okay. For the recording, okay. Like there are more people coming in, let them come. Okay, guys, this is Spit's workshop, and I will be covering. I'll try to cover two products that we have bounties for, and please ask questions anytime. There's no AMA afterwards because I'm very hard limit on time, 30 minutes. So I won't spend a lot of time explaining what PITH is. This will be more of a hands-on workshop, so you can see how to use it because it doesn't take more than 5 minutes to implement PITH in your dApp. So PITH and Oracle, we supply price data, we supply random numbers. Two things. So price data can be crypto assets, indexes, metals, redemption rates, meme coins also sometimes. Now we have some meme coins as well. And gold, silver, all commodities as well. And how it's different from other Oracle? It's a pull-based Oracle. The difference between a push Oracle and a pull Oracle is in any push Oracle, what do you have? You go to blockchain and tell, bro, I need ETH USD price. You're like, okay, go and read the data on the state. That's how any blockchain or any Oracle work. But in this case, you have to pull the prices. So I'll explain you what do you mean by pull the prices. It's fine. Okay. So let's get directly started with the code so you don't have to understand everything and just do things. I'll do it in front of you in Remix. Okay? So this is the exact code that, yeah, I'll zoom it. Sorry. Okay, this is the exact code that you will see in the documentation. I will traverse the documentation in front of you so that when you are building, you can see what I did and you will remember with that. So if you go to documentation, and this is the landing page, you go to documentation. If you're building price feeds, I will recommend you to use the guides here and click here in EVM contracts. And we have a code, an example code. So if you see here, what things are there? There is one constructor in which you have to pass the PITH contract. What's that PITH contract? How can you get that? I will tell you afterwards. That's the first thing you need. Second thing you need, which prices do you want to read? Depends on application. If you want ETH USD price or BTC USD price, you need to know the ID of that you want to fetch. That's a second requirement. Third requirement, the last requirement is you have to pull the prices. So three things. One, you need the PITH contract address of that chain. Second, you need the price feed ID that you want to fetch. And third, you have to pull the prices. That's all the things you need. So this is the main chunk or 3 lines of code that you will write in your code to fetch the price. This is an example method. If you see, we have the most important line which will make you eligible for bounty. A lot of people who tries to use PITH, they do the same thing like other oracles. Go get price no older than, or get price, and they say I'm getting an error, I'm not able to get the price. Reason is you have to update the price feeds by yourself. The reason is we can't give you prices every second on the chain. So whenever you need the prices, you update at that moment. So by using this, you can get prices every 400 milliseconds. That's how fast PITH is. Yes? Yes. Yes. So exactly. So get price no older than means you enter the price feed ID and you have seconds. So if you say 60 seconds, so if the price that is updated on the chain is older than 60 seconds, it will give you stale price. Simple. And if you update the price, that means on that chain, that price feed is updated. So anybody can read the price for everyone. Simple as that. One way. That's all. So every price update causes like gas cost plus one way. And even this price update, if you see, there's an argument that you have to pass. This is a price update that you will fetch, the third requirement I told. You can send 100 prices together in one argument. And that's why we have one line which is like get update fee, which will see how many prices that you're passing in this bytes and will tell you how much fees it will incur. So if you're sending one price update, one way. Sorry. So you do get update fee, you get the fee, you send that value fee and the price update, you fetch the price, you're good to go. That's all you have to do to get eligible for bounty. Forget about bounty, that's all you have to do to fetch the price. We have one question, yeah? Yeah, I'm pretty sure we have 540 price feeds. And in one time you can update up to 200 or 250. 250 way, I don't think anybody is high for anyone. Yes. No. So this price update will have the price. This update will verify the price that you brought is right or not. That's the first thing. And second, it will update the state on the chain. This will already have the price. But when you are, this you have to fetch from off-chain. That's the next part I will show. So when you fetch from off-chain, I have to make sure that you're not changing the price in between before sending in the contract. Yes. Yes. Till now, everybody is okay. 3 requirements. 1, we have to find the contract address. 2nd, which price feed ID that I have to fetch. 3rd, pull the prices. Now that's the trickier part where people don't realize that they have to do it in Pyth. So how to fetch the prices? So there are 3 ways to do it. Like we have our APIs, we have SDKs, or you can stream the prices. So if you see in this document on the left side, we have fetch price updates, a whole page. So you can directly fetch from a curl API, which will give you like a data like this. I'll show you in practice as well. A data which you will pass, okay? Or you can stream the price, or I'll suggest use this SDK in your app because you will write a front-end code in every application you will build. Just write this SDK, call this. Hermes is the Web2 API which will help you to fetch this price update. You send the price IDs, get me price feeds up to you. This is get latest price updates, send these price IDs, you have the price updates. That's it. So I'll show you how it will work. So the same contract that I showed you, I'll run it in Remix. This is the same contract. Nothing has changed. I'm using ETHUSD. I'm hard-coded the price feed ID, but I don't need to. I am zooming out because it is difficult for me to do it like that. Okay. Let's compile this. Compile. Okay. Which chain do you think I should run it? Let me see how much I have. This is Sepolia, so I'll run it on Sepolia. Okay, now I have to pass Pyth contract. This address, how will you fetch it? If you see in our documentation, we have a reference material, we have contract addresses. This is here. You go to EVM, and these are all the chains that we support on mainnet, and these are all the chains that we support on testnet. So I believe we cover everything that you want, especially in EVM space. You won't have that complaint. So let's find Sepolia here. Yeah, we have so many Sepolias now. Yeah, here it is. So I just copy this and pass it in my remix here because I need to deploy it along the constructor asked this. So I pass this Pyth contract address, deploy it, transact not payable. Sorry, what's? I think I'm doing a wrong one. I think this is. Yes. Oh, okay, I've selected the wrong one. Yes. Yes. So I'll add it here. I don't know, something wrong. My MetaMask is not taking the Sepolia one. So you just pass that contract address and you deploy it. Now, after that, you will go to Hermes that via either API or SDK, up to you. And we have a Swagger file also, so it will look something like this. So, for example, you want ETH USD price, and I'm passing it so that you can see. When you execute it, you will get this bunch of binary data. This is the price update that you will have to pass in that method that I show you, example method. This is the thing, main thing. Exactly, this is the call data. Just remember, because in Solidity, every string is represented by 0x, just add 0x here. We have not added 0x here because we support Starknet, Solana, everything. So it will create a lot of confusion. So just add 0x, and there'll be no errors after that. Just pass this and run your contract. And don't forget, that method has to be payable, so you have to pass some fees. So that's how normal price feed work. Wow, I'm fast. So we have a lot of time. I'm being very fast. So let's 5 minutes. We'll talk about price feed if you have any questions, and then I'll move to the next bounty. Yeah, this. You will get the price in this variable, and you want to use up to you. Yeah. So it is already updated here. The option data you passed, that binary data I showed everyone, you passed here. You update the data here. The PITH contract on-chain is already updated. Now you just have to read it by here. So off-chain Oracle is not fetching directly. You are fetching from off-chain Oracle, from Hermes that I showed. So I'll try to run it on Remix.
Yeah, I think my question is like, because like the smart contract on chain cannot call the off-chain oracle, right? So how can it pull data from the off-chain oracle?
So you are pulling the data from price update. How we are verifying the data, I believe that you're asking?
Yeah, like how to
Yes.
verify it
So
with the
send-
off-chain oracle.
So it's not, okay, the off-chain Oracle, we send Merkle proofs of every price via wormhole. You don't have to worry about it. We verify the prices on the back end via wormhole.
Yeah, I would just wonder how that works.
It's just wormhole is a bridge. It's a cross-chain bridge.
Oh, you just send like a message.
Yeah, we send the proofs of prices that you guys are not changing the price between the way. That's how it works. I can explain the architecture afterwards.
Okay. Yeah.
Okay. Okay, let's go to the, if this is clear, I believe, to everyone. Okay. So 3 things. You need the contract addresses. You will find the contract addresses from here. Second, you need the price feed IDs. All the price feed IDs are here. In this page, this is a price feed catalog ID. It will look something like this. So you can find everything. And third, you need to pull prices. How you can pull prices, the whole guide is written here. 3 things, that's all. Now, coming to the random number generator, the product we have called Pith Entropy. Using that, you can generate random numbers. And how that works, it's very straightforward. For example, you need a random number. You come to Pith and say, bro, I need a random number. And what I will say, it's like a commit reveal protocol. What's a commit reveal protocol? I'll say you submit a random number by yourself. Could be anything. And I will submit a random number by myself and will submit the hash of the random number on the chain and will commit it. Once anything is committed on blockchain, you cannot change it. Agree? In the next block, I will ask you, now show me your random number. And I will also show my random number. And we will verify each of the random numbers using that hash. Once that is true, the final random number will be hash of both. That's how it works in the backend. But what you have to do is the contract will look something like this. Simple, 2 methods, that's all. You have to call only one method. So you want to request random number. What I told you, you have to submit one random number. It could be anything, you submit that. You submit your random number in the argument. Its default provider use that. The provider is the one who will send the random number to you. And this is the thing you have to call, request with callback. When you request with callback, get the fees just like price feed that we did. The entropy provider address, it's in the guide I'll show you, and your random number, it will send back a sequence number that you store up with you. And you have to implement this method in your contract, which will be called by the provider. Like a callback we have in ERC 1155-721s, a callback method. So our provider will call your contract by this method. So you have to implement this method, entropy with callback. We will, like Pith provider will call that with the random number, final random number. That's it. So you have to just do this. And in the next block, or the reveal time for every chain is different, we will send you the random number. For every testnet, we'll send you in the next block only. That's it. You have to call this, we'll call that. And you can generate random number with any JavaScript library like crypto, Web3, Ether, even VM. No, VM doesn't have random number now, but every library have that. Any questions? Yep.
Yeah, just about like the bytecode that we can put inside the entropy callbacks. Are we limited? Like, I mean, it will be PIF that's going to call our callback, right?
Yeah.
So we just in terms of bytecodes that could be executed, we are limited. I mean, or should we? I mean, about the design, should we store the random numbness and then do the process we need to with this number afterwards, or we can do it directly inside the callback function?
You have to do it in the callback function, and the limit for that callback function is 500K gas limit. Okay. Because we will call that method, so we are paying the fees for that.
Okay.
So we have to put a limit. So I would always suggest, this is, because since this method will be called, in the same transaction you want to implement your logic, because if that transaction happens, people will know what the random number is in the next transaction. So I will implement a callback logic here, or your random number, that how you want to use. Any other questions? I'm going very fast. I know that, because last time, every time I've done this workshop, I go very slow. A lot of questions come, and I skip the entropy part. So we have time. You can ask questions. If you want me to repeat anything slowly, I can do that. Yes. No, it's not like price feed. This is completely different. We are not getting the random numbers from the same Oracle service that we have. The flow is also not same. No, no. It's completely different. Don't confuse with price feeds. Price feed is pulling the data. This is like, I need random number, just send me that. No, Oracle doesn't post the data. You pull the data. That's the difference between push and pull Oracle. When I showed that you have to go fetch price updates like this, remember? When you call this API, the data you see here, which is highlighted, is the update data, the call data, and the price will look something like this. But when you submit this here, I'm using my left hand, sorry. That highlighted binary data, call data, you have to submit here. It already contains the price. But you have to verify the price if you're using it on chain, and that's where this happens. So you have to pull the price. That's a catch. If you see in the bounties that I have mentioned, I've mentioned many times, if you don't pull the prices, you won't be eligible for bounty. You have to pull the price. But if you are building something and you want to integrate many oracles together, and the interface would be different for every oracle, you can run a bot which will keep updating the price. We also have that bot. It's another document. I'll share that. So you can also do that. So I'll check each and every code, how you are updating the price. So you have to update the price. This is the crucial part. You have to fetch the price, update the price, consume the price. 3 steps. And 3 things that require the contract address on any chain. That, like, if you're deploying on Blast, you search from Blast, what's the address, put there. Which feed do you want? You fetch the update data for that, consume it. It's storing and verifying. 2 things are happening in the backend when you run this. First, it verifies that, okay, you fetch the data from an off-chain service. The Ethereum price is $3,500. You change it to $3,700. And you tell Pith, update the price. It is wrong. So here, that update checks that, have you changed the price or not? How? It's like every time you fetch the price from off-chain, we send a Merkle proof of that price on-chain, not the whole thing. It's just a proof. And we check computing the Merkle proof here and here. If they're same, that means you have not changed anything. That's clear?
So it's like when we call that get the price.
Yes.
So the user will get the price from one pass.
Yes.
And then the provider will submit the Merkle tree through another
it's already
pass.
submitted all the time. So
Okay, gotcha. So in the contract, it will verify,
Yes.
like compare those two. Okay.
Exactly. So it will first verify and update the state. So you're just reading the state here. Simple. And you can combine 150 or 170 prices together in one update. So you don't have to call transaction again and again. So that's how you can fix it. Yes, like this. If you see in this, in the same API, I can add many. Like right now, it's replicating the same one, but you can add many. If you execute, it will give you one data, a bit longer, of course, but you pass this only. So right now, if you see, I have passed how many? 5. And if I go here, so if I pass that 5 price fee data, the fees here will be 5 now.
But does that rely on the execution of this transaction and the Merkle proof are submitted in the same, have to be in the same like block?
No.
So what if like this logic is executed at block 1, but the Merkle proof?
So Merkle proof is not submitted like that. When you update the price feeds, our contract will fetch it from the wormhole. So don't worry about the Merkle proof from your end. We will verify it. We fetch it Merkle proof from the wormhole at that point of time. We verify it. So everything happens in one transaction.
So with the VRFs, is it with REN?
Yeah. So with VRFs, why do you need callback to specify upon like
in the first transaction that you send, when you request for callback and you send your own random number, we commit it. If we can't send this random number same transaction unless you commit your random number. Like, what if you change the random number? So that's why callback happens in the next transaction and we send you the random number. That's why the callback mechanism is there.
So in the next transaction, you'll call my function in my smart contract that I specified in the callback?
Yes. So it has to be the same interface, like reveal with callback. I'll open it again. Yes, entropy callback. So our provider will call this method on your contract and with the random number, and you will implement logic inside this method only.
To work with that random number.
Yeah, if you want to use random number, it's coming in the argument so that you can use in the same method.
Well, I can just store it in the storage, right?
Okay. Then,
right?
Yes.
Okay.
If you store it and then call another method in the same transaction, then it's fine. But by the next time, everybody can see the random number. So what's the use of that random
Oh,
number?
yeah. It has to be used immediately in the scope, right?
Any other questions? We have time. I can okay, I'll show you some other things so that it's easier for you when you're building it. In the documentation, if you see, for the entropy, we are only available on these chains. But for price fees, I showed we had a big list. These are all the main nets. And we have test nets as well. I'm pretty sure you'll be using test nets. These are all the test nets. And this is the provider address that you will send it to the contract.
Wait, that's for randomness?
Yes, that's for randomness. I'm talking about randomness right now. And the fees varies for like, these are the fees. So you don't have to copy the fees from here. You will use the on-chain method to fetch the fees, which is written already here. Get fee. So the fees for price feeds and the fees for entropy is not same. For price feeds, it's one way per update. For entropy, it changes as per the chain. So you can generate thousands of random numbers in one transaction. Can you guess how?
Well, like that array of like the same, you said you asked for randomness, right?
Yeah, randomness. Like I gave you one random number. You can generate 1,000 random numbers out of that.
Oh, they're like hashing?
Yeah, you can hash it. You can use a C to hash it or anything. So that's right. So if you see, we have something like reference material, best practices. So you can generate multiple random numbers in single transaction. So with a callback, you can just encode pack, hash it, and have multiple random numbers with one transaction. So you don't have to pay for 10 or thousands of random numbers. Just hash it with different seeds. That's what ABI encode packed with Kekak 256 does. So I'll recommend everyone to use the guides. They are short, they're crisp, and they contains everything.
How up to date are they?
I updated it. Don't worry.
Today?
So we have not changed anything in past few months.
Okay.
But I keep updated some reference materials and all the contract addresses are updated. I'm just putting an update. I'm pretty sure it will go by like in 2 hours. But if you go to price feed IDs page, these are the price feed IDs for prices. Even though you're using mainnet or testnet, don't get confused by EVM beta or stable. Don't look at this. These are all the price feed IDs you need for Litecoin. I don't know why it came to my mind.
Yeah, so the price feed ID always stays the same across testnets and
exactly.
every chain?
Every chain, irrespective of EVM, non-EVM, Solana, or whatever you want, price feed IDs will remain unchanged.
Okay. So then, like when I switch chains, I only look to switch the address of the oracle.
Exactly.
Okay.
And the price update that you fetch from home is chain agnostic, doesn't care about chain. So you just have to change the constructor Pith contract address. That's all. So when you switch the chains, you have to change this. That's all. I have 30 more seconds. And I've spoken a lot. For price feeds, right now, think of any use case where you need a lot of prices together or very frequent prices. Trading, like almost every perps out there use us. Or DeFi applications are switching to Pith because we can send you data every 400 milliseconds. And for any random number, gaming, lottery, anything like that where you need random numbers, you can use it. Exactly. It's cheap. It's all permissionless. You don't have to contact me, dude, I need random numbers. Yep. Yep. It's doable. So you
Sorry.
can make this oracle as a push. Just answering the last question.
Sorry, can we please go to their booth to
Okay, yeah.
continue this
I'll answer
conversation?
that.
We have
Thank
to
you, guys.
continue with the next talk. Thank you so much.
Hello. Hello. I will start for the recording because we are recording as well. So BitDSM is we hacked it in ETH Singapore just 2 months ago. So it's a new bridgeless way of bringing your Bitcoin to Ethereum smart contracts. So we leverage EigenLayer, and it's exactly modeled after EigenLayer pods. So what happens? Think of it like a pipe. So if you're a Bitcoin user, you use Electrum or any other wallet, you just do a one-click deployment of your BOD on Ethereum. So what happens is your Bitcoin address gets mapped into the Ethereum. You open a 2x2 multisig with the EigenLayer operator. So your Bitcoin gets logged in your wallet into the multisig, and they get released into the BOD. So yeah, that's better. So now, as they are released into the Ethereum in a smart contract, user still has the control of it, but it's not ERC20. It's like a smart contract. You can put conditions on it how you want to spend, like that smart contract. So as an app developer, you can get hold of that smart contract. You can lock it. So if, let's suppose, I was your user, I locked 2 Bitcoin in my wallet on the Bitcoin. 2 Bitcoin are available on BitDSM, and then your app is locking it. Let's say you are a stable coin, or you are minting an NFT backed by Bitcoin or something. You have locked the bod. So you have the 2 BTC available in your app now. So the app has the capability to liquidate you as well. Like depends on your own conditions. Yes, yes, because it's a 2x2 multisig with the operator. So liquidation is possible, but user has to read your contracts and verify everything before giving you the permission to do that, before signing up to your app, basically. So that's how BitDSM works. Any questions? Solidity, yes. This is all smart contracts.
If me, as the user of the Bitcoin wallet, I want to transfer that BTC, those satoshis, those are locked, right? So if I try to move them, I cannot do it if there's a condition on the EVM, right? Because we have the MPC wallet, right? Oh, okay, perfect, perfect, perfect. And does it work with runs or only with BTC right now? Okay. Okay, perfect, thank you.
So yeah, I'll let Usman explain how this works in a dashboard, and he will show you the app registry contract. So whatever app you're building, you can just register it through a command with BitDSM, and you will get access to lock and unlock functions of that BTC. Yeah, got it? Yeah, that's fine.
So, hi. So this is our basic. I can't speak. It's on? Okay, nice. Okay. So this is our basic dashboard that we are using for these contracts that we are having. So this is live on Holisky and Signet. So right now we are using the BTC from the Signet testnet. So as a user, you can go and deposit your BTC by creating a bod. So the first thing that you need to do is to use the OKX and link your account with our dashboard. So this is already linked, so I will use a new account, let's say this one. And if I connect it here, so this should pick up my public key. And if I go and create a bot, so what this will do is, this will create a bot that is linked to the public key that you are using to sign the transaction from your wallet. So you own the contract that will be deployed as a bot, as a user. So we don't own it. So if we go and do a create bot, so we have a list of operators that you can choose from. So this is the set of operators that are basically registered on EigenLayer and staked there. So you do a multi-sig with these operators on the BTC network, which will become reflected as a value on the bot contract that we are deploying here. So you can select anyone. Let's say I select theta. So this will create a transaction that will be sent to our contracts. And this will also create a multi-sig address on the Bitcoin network, where you can deposit your BTC, which will be reflected into our bot. So Signet is slow, so. Okay, so your pod has been created. So here you can see this is undelegated, and this is the address of the pod that is now deployed on the Holisky network. So as a next step, you can go and basically fund your pod. So you can select the operator with which we wanted to fund. Let's say I wanted to deposit 0.001, okay, fine. So this is now taking confirmation from me. That will create a BTC transaction. If I confirm it, and So if you confirm this, so this is basically creating a BTC transaction that is sending your funds to the multisig that you created when you created the bot, as well as registering the bot to our contracts so that we can verify the request. It's taking a lot of time. Okay, so this has basically created a transaction on the Bitcoin network, but as you know, Bitcoin is slow, so it will take some time. So what I can show you is I have already a bot that I have deployed that is already funded. So I can show you how can I delegate it to the applications, which is more useful for you, I think. So I have an account here, let's see, this one. So as you can see, it has already 0.001 BTC staked. So this is already funded and it is delegated too. So let's undelegate it first. Okay, confirm. I can't do anything. It's slow. It's a test net. Yeah. This is. Okay, so yeah, that's done. So we have a pod that is deployed and funded. So we can just go and delegate it to the applications. So this shows you a list of applications which are now registered with our BDSM contracts already. So these are some sample applications that we have registered. So you can select any one of them which you want delegate to. So let's delegate. And what this will do, why is there an error delegating? Oh, let's try again. Sometimes it just does the problem. I have to see. The delegation is false. Okay, maybe I need to refresh. Yeah, let's go to the smart contract. So basically it's just a call to the contracts and the mapping inside our BDSM contracts get updated and we assign the pod to a specific app, which is basically being funded here. So this is just that. This is just a contract callback. I can try it once again. Sometimes the contract just gets stuck somewhere. Let's see if I can call it. No. It was working. It undelegated, but now I don't know. So anyway, so we can go to the contracts, I suppose. So these are our basic contracts that we have deployed on Holinsky. We have the Bitcoin pod with the pod that we saw, a pod manager which actually manages the deployment and the assignment of the pods to different addresses and maintains the storage information. Then we have the BitDSM registry and the service manager. This is eigenlayer related, so that's how we get the operators registered with us. And the operators are also responsible for verifying the transactions on the Bitcoin network. So the verification is dependent on the operator and the operator is staked in the eigenlayer. So if there is any malicious transaction or the operator does anything fishy, we can stake him on the eigenlayer. And so the most important thing is basically the app registry where we register the apps. So any app developer can come and register with us and have access to these bots that are being deployed by users and funded with BTC. So the main function that we require is basically register app. So you just have to provide the address of the app and a signature on a digest that you can calculate using this calculate app registration digest hash. So you just first call this function and calculate a digest hash, then create a signature on it, and you just pass that signature and the digest hash to this register app, and this should be enough to register you with our app registry. Once you have registered with our app registry, then you can update the information of your application using this update metadata URI. So this helps us pick up the information related to your contract or related to your application, like name, website, description, if you want to put something. And this helps us put that information on our dashboard, the way I shown you earlier, where I showed you the list of the apps. So if you can, so you register through this one. And what else? So if you want, you can also deregister back. So once you deregister, you also have to release all the pods out of it. So we have created a very basic example to show you the locking and the unlocking, which is actually available on our BitDSM GitHub as a BitDSM examples folder. So if we can go back there, that's a script. So we have provided these reference scripts for registration and deploying on app so that you can look at the code. And so if you want, I can go through it. So basically, this is a simple time lock app, which is provided here in the examples. So it does, so what it does is basically locks an app for a certain period of time and then unlocks it when the time has expired in terms of number of blocks. And what it uses is the pod manager to lock the app. So basically, you can import the pod manager using these interfaces that we have provided already. And you can call this lock pod and unlock pod to lock or unlock the application with the pod. Right. So the registration and the deployment. So this is a simple application that we had for lock. So this was a deployment script which just deploys the main contract. And once you have deployed it, you just copy the address of the application and use this register app script to register it to our app registry. So you can see here, the process is the same. I've just called the app hash digest calculation. Once I have it, then I create a signature on it and just checking that the signature is valid. So another important point is you have to provide this valid signature function inside your app. Because we are implementing the ERC1271 contract-based signature verification. So your own app determines what kind of signature you want to verify. Is it a single party signature? Do you want to implement a multi-sig, or do you want to have a contract given the authority over this application? So it's up to you. So the only thing is you just have to override this as valid signature function in your own application and provide the appropriate logic there, and it should be able to register it independently. And you just call the register app function and it should be enough to register it. Apart from that, we also have a CDP example which shows a collateralized desk position. So it's a very basic example which locks the pod, which it gets from the app registry in this case, and then mints a ERC20 stablecoin given the liquidation and the collateralization that is provided by the user. But it's just two simple examples provided to teach you how to use the app registry and how to register the app and what can be done. So that's pretty much it from us. Is there any question? Sorry, I can't hear you. No, the Ethereum gas is paid on Ethereum. So there are two different kind of gases that are going down there. So there are two different kind of transactions. When you fund your pod, that funding transaction happens on the Bitcoin, so the gas is paid on Bitcoin. Right. The rest of the contract interactions all happen on the Ethereum, so you pay the Ethereum gas fee.
Okay, got it. Perfect, thanks.
That's the whole point of the application, that you move the Bitcoin from Bitcoin to Ethereum and make the value representation in a contract on Ethereum. Once it's there, then it's all Ethereum ecosystem. It's all Etherland.
Okay, perfect. Thanks.
Is there any other question?
Yeah, so I think that's it. We are offering bounties for the hackathon. So if you just register the app, whatever you end up building, you will be eligible for the judging for the bounties. Yeah. So, yeah. Thank you.
Hey, hi everyone. We are all gathered here to get to know more about what Protocol Labs has to offer for this hackathon. So let's get started. Prior introduction of me. So this is Rish, developer advocate at Field Builders, and let's get started. So let's get acquainted with what bounties do we have for this hackathon, starting with Filecoin Foundation. So you have 8,500 to grab, along with Storacha that has to offer 5,000. And then we have Akave, who is another on-ramp solution using which you can store data on Filecoin. So that offers you 2,500 USD with Swan Chain. If you have got any AI-based solution that you can build on-chain, so you got to try out Swan Chain. Last, we have Protocol Labs, wherein you can stand a chance to win 1,500. All right, this is perfect. Thank you. All right, so hackers in the house. So every time when you get started building your solution in hackathon, something you might want to have in your kit is a starter kit, wherein you can just spin up your front-end application as well as have hard hat and smart contract functionalities in it. And that's what FillFrame brings to you. So some of the features that you have if you want to build your solution on Filecoin is maybe you might want to have a smart contract framework. So FillFrame comes with automated framework using which you can deploy your smart contracts in just a couple of minutes. Then you have ready to use front end. So you don't need to build anything from scratch and you can just roll out your dApp in just 10 minutes. So we talked about various on-ramp solutions. So during storing your data on Filecoin, you can offer for various on-ramp solutions, like maybe it can be Lighthouse, it can be Storacha, or it can be Akave for that matter. Last, you can also have programmable storage as well as access control. So let's assume that you have any private data or you want to have some access control over the data, you can offer this solution as well. And with DeFi, you might want to have a look at cross-chain breach, and that's what we provide it inside the kit itself using Excella. So lastly, this is all about FillFrame, and you are now all set to power up your dApps. So how do you get started with? So this is the portal wherein you would find all information about FillFrame. So you can take a moment for a sec and just scan this QR code, and you should be pointed towards FillFrame. All right. So let me just navigate to that, and here you go. So this is the home page for FillFrame, and you can just build your dApp by just going to your terminal and hitting this 5 set of commands, and you should have your smart contracts deployed as well as your front end set up in next 10 minutes. So let's just follow this like a tutorial, and we would be good to go. All right, I will just open my terminal, and so the first command goes like we need to create a Filecoin application. So I'll just copy this straight away and hit it on my terminal. So what you would love to have your project name as, maybe I will just create a new frame. So I will go for my frame. And now we provide you an option as to what kind of starter kit do you want to convert this into. Is it something you want to use Storacha as the on-ramp service provider? Or is it Lighthouse? Or is it Akave? Or if you want to have deal client that is storing data directly on-chain without making use of the on-ramp service providers. So we have like 4 options over here. Let's carry on with Lighthouse for this demonstration. So it would create me a customized dApp for Lighthouse. So as you can see that we just started with and we have some error. So it just says that I need to use the node version which is compatible with the kit. So I will just switch it to this particular version. How do you do that? Yes. So I have switched to node version 20.9.0 and I should be good to go. So let's just hit the command again. I will just name it as new frame and select Lighthouse as my on-ramp service provider. Cool. It will take just some time to install all the node dependencies that are required. So you don't need to install it explicitly again and again. We have done all it for you. So here we have our project is all ready to roll out under the name new frame. So I will just enter the directory. I'll just open the VS Code. Perfect. I'll just zoom in for you. Let's have a look at the directory structure. So inside package, we have two directories for you. The first one for the deployment of smart contracts, and that you can access via hard hat. And the next one is Next.js, which handles all the front end for your decentralized application. So before deploying your smart contracts, the very first thing that you need to do is just edit the environment variables, and you will have to input your private key. So let's just do that. Perfect. So I will just grab my private key right over there. So if you are new to even MetaMask, I will help you out how you can do that. I have my MetaMask right open there. Just go to account details and it will just ask me to enter my password. Feel free to grab my private key. It's all on testnet, and feel free to use all the faucets right over there. Yeah. Perfect. So there we are, and I will just edit my environment variables. I have my private key right in place. So I just switch back to the terminal, and the first command I go for is compiling my smart contract, and that's yarn compile. So while our contracts get compiled, we can have a look at, okay, it's quite very fast, and we have our smart contracts compiled. So next step would be to deploy it, right? So let's just hit the command yarn deploy. So this command would deploy your smart contract straight on Filecoin calibration testnet. No configurations from your side required. The kit comes in with pre-built configurations. Meanwhile, the contract is deployed. Let's have a look at what kind of contracts is getting deployed right over here. So inside contracts folder, we have lighthouse nft.sol, which means that it's an NFT smart contract that is getting deployed. If you want to have your own custom smart contract, you just need to add your smart contract in the contract directory, and you would be good to do. Okay. So this should take around next some seconds while the contract gets deployed, and you can have all the scripts, the test cases for the smart contract written right there. The deployment scripts are also mentioned over here. So you just need to modify as per the name of your smart contract. That's it. Let's have a look if our contract is deployed. So it's still getting deployed. Let's give it another 15 odd seconds. And meanwhile, I will just make you acquainted with how does the front-end directory structure looks like. So if you go to Next.js, you have app section wherein you have various like navigations like Lighthouse. So all the integration is inside the Lighthouse folder itself. You don't need to navigate it further. Then various components like the assets as well as various pages, the routing you would be able to find out right there. Okay, and the contract integration and all the contracts can be fetched inside the contract folder. Perfect. By now, we can have our contract deployed. So our contract is deployed, and it's waiting for our contract to be indexed. And here you can see the contract is verified. So just need to have some patience right there that the contract verification would be in the next version of FieldFrame. For now, we have the contract deployed on the chain. So we are good to go. So now that our contract is deployed and our contract integration is done with the front end, we just need to hit the command yarn run dev, and within 10 seconds, 10 minutes, we have our front end ready. So let's head towards localhost. I will just enlarge this. Perfect. So let's just wait for all the files to be compiled, and we should be good to go. Meanwhile, I will just navigate through the FieldFrame website where you can see that what are the various components this particular kit comes with. So you have storage deals, you have retrievals, you can look at data DAO concept as well as how FVM exactly works and what are the storage proofs and smart contracts associated with that. And these are the 3 storage on-ramp service providers. We have Lighthouse, Storacha, and Akawe. Like we just discussed in few minutes prior, that you can integrate this on-ramp service providers to store the data directly on Filecoin. Okay, we have the front end up and running right there. And if you see that since we have like opted for Lighthouse as the on-ramp service provider, you can just navigate to Lighthouse tab by clicking on it. And we have like couple of options here. The first one is mint a private NFT. So we learned about access control feature, so you can opt for that. But for you to see my NFT while we mint it, I will opt for mint an open NFT. So let's just choose a file from my, maybe I'll just select this. This looks good. So I've just chosen my file that I need to store on Filecoin, and I will just send a transaction wherein it will mint the NFT, create the metadata of the NFT, and transact that on Filecoin. So you can already see the CID of my file is generated and my data is already stored on Filecoin via Lighthouse service provider. So this should take roughly around like 30 odd seconds, and then your NFT would be displayed there. Along with that, we do have some starters where you don't need to navigate through various documentation of WAGMI, and you can have how you can actually read data from your smart contracts there. So you can see like there are 3 variables which I have. The first one is get total supply, what's the name, and what's the symbol. So the name of the NFT is Lighthouse NFT, and the symbol is LNFT. And here you can see that it automatically fetched and displayed my NFT once it got minted. So don't need to worry about anything, and you can just, maybe I'll just refresh this parameter, and here you can see now the total supply has incremented to 1, since now this particular NFT collection or the contract has 1 NFT in its store. So that's how quickly you can just set up your application. So you can just, if you are someone who comes from like working more on the contract part, you can just spin up your front end as well as deploy the smart contracts in 10 minutes. So I hope the hackers would love this. And meanwhile, we wrap up with this demonstration. You can see that you can switch between the networks. So we have integration with Filecoin mainnet as well as calibration. So you can do that as well, as you have like the facility to disconnect your wallet and connect back at it again. Also, you can copy the wallet address as well as display the QR code if you want to share your address or need that feature in your application. So that was pretty much about how you can make use of FieldFrame. Maybe I will just go back to my slides and let's have a look at it. Like if you missed or like you want to revisit how to make use of this application. So this is a tutorial wherein you can just revisit the whole session and just relearn about how to use this FieldFrame starter kit. Perfect. Let's just wait for, I can see some folks still scanning the QR code. So let's just wait for them. Can you scan it? Yeah, perfect. And in case like you missed, wanna have like complete support during the hackathon, you can just join our Telegram, which is built specifically for this hackathon, and we would be always there to support you and resolve your any doubts right over there. Awesome. So that was pretty much about building a decentralized application on Filecoin and spinning that up for the hackathon in 10 minutes. So that's what we did in exact 10 minutes as well. So that's a good one to go. So if you have any questions, we can discuss that.
Okay. Okay. The first question is exactly how can an app qualify for any of the bounties? I heard that it's not enough to use IPFS. You actually have to use Filecoin.
Right, so that's an interesting question. So what I would suggest you is like if you want to store the data on Filecoin, so Filecoin actually guarantees you the data is stored securely. But on IPFS, you don't have that guarantee. So if using this on-ramp service providers, they does the same thing. They have a JavaScript SDK using which you can integrate in the same way you store the data on Filecoin, but on IPFS, sorry. So using Storacha, Akave, as well as Lighthouse, you can, just store the data on using this on-ramp service providers, and the data would be directly stored on Filecoin. So that's the thing you need to do to become eligible for this bounty.
Oh, so we have to, so to qualify, it's to use one of the providers.
Exactly.
Okay.
Yep.
Hi. So I looked a little bit into it, and it said like you need to have the storage deal made on Filecoin. But then when you look at the Lighthouse documentation, it says until the storage deal is completely finished and it's verified on Filecoin, it can take up to 2 days, which would be like the whole hackathon. So how is that interacting with the bounty?
Right. So when you are making use of Lighthouse, it's an on-ramp service provider. So it doesn't store a single file in Filecoin. It would be aggregating all the data. It will bundle up and then store it. So if you are using it, the Lighthouse SDK would still provide you a callback wherein you would be like getting the result that your data is securely stored. Even if it takes like couple of days or whatever time, it won't take that much of time, but you would be assured that your data is securely stored and the deal is getting created.
So even if we don't have the Filecoin storage deal yet via Lighthouse, that would be okay with the bounty?
Yep. This one? Yep. Oh, okay. This is the website. Yep.
Okay, I want to ask about so field frame framework is on-chain data storage apps. What make it distinguish from like Web 2 data storage like AWS S3 or AWS S3? What make it distinguish beside of decentralized?
Can you just come again? Like, can you talk?
Okay, what make Filecoin distinguish from Web 2 file storage like AWS S3 beside of decentralization?
So the very first thing is, it's if you just navigate through Filecoin documentation, you would find the comparison between the existing centralized solution for this. Filecoin is way more cheaper data storage, as well as you have an option to, the one who is storing the data, he can't see your data exactly. But on like any centralized solution or any existing Web 2 solutions, they do have access to your data, right? So that's the first one which you can say. As well as you get an option as to how many replications of your data do you want to make. As well as which service providers do you want to store the data, and for how much amount of time do you want the data to be stored. So this all customizations, apart from just being a decentralized solutions, you get these features as well.
Okay, thank you.
I guess that's it, and we are ready to go. Happy hacking, and excited to see you what you built on Filecoin. Thank you.
check. Hello. Yeah. Hello. Yep. Okay. Hello, everyone. Thank you for joining this workshop. So today we are going to be covering how to deploy your own rollup in under 15 minutes. Bold claim, we have 30 minutes, so let's see if we can actually deploy something in under 15 minutes. Essentially, I'm Robin Devrel from Avail. Avail is this modular tech stack for rollup builders to overcome challenges such as scalability, interoperability, and security. What that means is like DA is what we have as our main primary layer. On top of that, we are building something called as Nexus, which is going to be this interoperability hub. And then we have Fusion, which is going to enable multi-asset staking. Right now, as hackers, the main thing that you want to focus upon is the DA layer, which is short for data availability, right? So what we want you to build, or what we want to enable you to build, is highly performant rollups. So we are a rollup infra tech stack. So what is Avail DA, right? Avail DA is this validity proof based DA layer for building trust minimized applications essentially. What do you mean by DA? What is DA? Essentially, rollups, for them to function, they need data. Rollups actually handle execution of user transactions, but in order for them to actually be secure and verifiable, even if it is an optimistic rollup or a ZK rollup, you need the transaction data or the block data behind those, behind that execution to be available. So traditionally, what rollups did was they posted this data to Ethereum, but they did it via this method called as call data, which was expensive, and they realized that it is too expensive. We need either alt DA mechanisms, or we need to make the DA layer like Ethereum cheaper. That's why they introduced blobs. But blobs still can be expensive once there are people actually using it. So that is where Avail DA comes in, wherein we are enabling trust minimized DA with the help of light clients. Light clients do this magical thing called as data availability sampling, meaning that they can trustlessly verify that the data on Avail, or whatever data that has been submitted to Avail, is actually there and it is available via a technique called as data availability sampling, right? So we use things like ETHG commitments and block erasure encoding to enable this, but I'm not going to dive deep into all of that right now. So you might ask, all of that is fancy words. What can I actually build on Avail? Building on Avail is actually pretty easy because we've already got integrations with all of the top stacks out there. So it all works under the hood, and you don't really have to worry about what DA is or what what Avail does. You just need to deploy a rollup and focus on your application without worrying about the infra side of things, because that is already integrated for you. So what can you build? You can build anything from RWA, or like real world assets, gaming applications, anything that is related to ZK, DeFi, like high frequency DeFi applications. And the power, like the powerful thing here is that we support complex environments. We're not like just someone who we don't just support like EVM or SVM. We support any arbitrary execution environment. This can be a move VM, a WASM based runtime, any VM for that matter, right? So that's pretty cool. So how can I actually do this, right? So we've got a couple of stacks and frameworks that already allow you to do it, such as OP Stack, Arbitrum Orbit, Polygon CDK, ZK Stack, Madara, Stacker, Rollkit, Cosmos, Sovereign, SDK, all sorts of stacks there. But for our bounties at this hackathon, I think you already know that we have an Arbitrum Orbit bounty, and we have a bounty with a team called as Cartesi. And I'll dive deep into that moving forward. But essentially, all you have to do is deploy your application using either Arbitrum Orbit or Cartesi, and you can actually win prizes. So how can you use Avail in this upcoming hackathon? One, build a rollup. Building a rollup can be It can be a general purpose chain, it can be an application purpose chain, it can be a purpose-built chain. It does not matter. As long as you're using any of the stacks that I mentioned before, you can just deploy a rollup like instantly, and it behind the scenes already submits data. You don't have to worry about anything there. Now, you maybe don't want to deploy a rollup. So what do? You can build any application. So it can be any application out there, but you want some way to submit data or publish data to some network to make sure that that data is available in some shape or manner. In that sense, then you might want to submit that data to Avail. So you just want that application to publish data and to be able to verifiably retrieve that data. You can use Avail. And the last way you can probably think about using Avail is if you are building some kind of ZK application where you want to maybe store the proof or maybe the inputs or the data behind that computation somewhere to be verifiable so that anyone can pick up that data and prove it themselves. Something like that. You can again submit that to Avail. So in this flow, you can see like you are the user. They interact with the application generates some proof, and they submit the proof to Avail, and then you can retrieve it later on, right? So those are some of the ways in which you can build on Avail. The primary way in which you would build on Avail is by building a rollup or an app chain. So why would you want to do that, right? So a couple of reasons are dedicated throughput and block space. So if you know, like you might be already familiar with this, if you are actually deploying your smart contracts on like Sepolia or Wholesky or any testnet out there, the problem is that you are sharing resources with maybe millions of other users. That means there's going to be congestion, the block times will be variable at times, you don't get consistent throughput, right? By actually deploying your own app chain, you are able to get independent block space, dedicated throughput. You are able to be flexible with your product, as in you can deploy your own chain with your own product features that you want. For example, you might want native account abstraction, but there might be an OP stack that you want to build upon, or Arbitrum Orbit you want to build upon, which does not have native account abstraction. So you can deploy your own chain, you can configure, or you can basically modify the Arbitrum Orbit stack to use pre-compiles that can help with account abstraction. So you can do all sorts of stuff such as that. We have all VM support, low prototyping costs, low cost of experimentation, which might be also helpful for you. And also, cool thing, if you want to go live into production mainnet, you can also configure your chain to have a custom gas token, so you don't have to pay in ETH. You can use your own token for that, so that might be also interesting for you. I mean, you can use any ERC20 token for that matter. So so if you want to look at how your project as Avail works, you can reach out to me. So as far as bounties go, we have two main bounties, but a couple of others as well. The first one is we have a joint bounty with Cartesi. So Cartesi is also right beside us in the booth, so you can actually check them out. So what Cartesi does is they allow you to deploy Linux-powered rollups, meaning that you have chains that run on a Linux environment. So no matter what you do, so anything that you build, it can leverage the already existing Linux developer tooling, environment, etc. That means you just have to code your application in any language that you know, like it can be Go, Python, whatever it is, and you can just deploy. How it kind of works is you have a transaction which is being sent to an endpoint, and that transaction is being picked up by Avail, and it is being sent into the Cartesi layer, and Cartesi processes it, and all of that good stuff. And then we also have some other prizes as well, such as we have a pool prize. So if you're not building a rollup, or if you're not building anything with Cartesi or Arbitrum Orbit, if you're using Avail in any other way, like submitting data to Avail and retrieving data or doing something with that, you can be eligible for some pool prizes. If you don't want to build, or you couldn't build as much, but you want to test out our docs, we have developer feedback. And also, if you want to explore the Avail ecosystem, and if you think there is some core infra or tooling that you can actually provide, such as developer dashboards or validator tooling or something like that, and if you want to kind of actually try and enrich the Avail ecosystem, we have a best core tooling project for Avail prize bounty as well. And also Arbitrum Orbit as well. So we have a total of $15,000 in prizes. So you can check it out. Also with Cartesi is the good thing about the Cartesi and the Arbitrum Orbit bounties is that it's kind of like a joint bounty. So if you build with Avail and Cartesi, we are sponsoring $5,000. Cartesi is also sponsoring $5,000. So it's like overall $10,000 you are vying for. And also same for Arbitrum Orbit. They have around 5,000, if I'm not wrong, as their bounty prizes for Arbitrum Orbit. But if you use Avail ZA as your, in your project, basically you can spin it up. I'll show it to you now. But if you do the Arbitrum Orbit and Avail integration, not only do you get like the $5,000 from Arbitrum Orbit team or from the Arbitrum team, you can also win prizes from the Avail team, which is another $5,000, so another $10,000 for you. So yeah, you might want to check that out. So before I actually open up for any questions, I can show you how to actually do this. So Arbitrum Orbit, I think this is what we have natively in our docs. So Arbitrum Orbit is this EVM compatible optimistic roll-up based stack. You can easily deploy this. All you need is Docker. You need some Avail tokens to actually do the DA submissions. You need to create an application ID, and you can actually do that by actually going to appid.availproject.org. So if you go to appid.availproject.org, you see this amazing page where you can actually go to, you want to build on testnet, so make sure you switch that. Connect your wallet. So I have my wallet here. Cool, I'll just, yeah. So it's connected, great. Now I can actually create an application ID. So what is an application ID? Why do I need to care about it? So in Avail, the blocks, basically every block in Avail is categorized or segmented into different app IDs. Why we do this is because if you are a roll-up or if you are building an application, you don't want to download the entire block to do something with the data. You are just submitting data and you want to only retrieve the data that you've submitted. So in order to filter through that, you can actually use the app ID metric. So anytime you are submitting data, submit that data via an app ID. So whenever you filter it out, you can get it back. Right? You just have to download data particular to that app ID. You don't have to download the entire block data because that would be really big. Like, yeah, our current block size is around 2 MB, so you don't want to be downloading the entire 2 MB block, right? You just have to download data specific to you. So that's what app IDs kind of enable you to do. So how would you do that? You can go to create here. You can put in any name. For in this case, ETHGlobal Bangkok. Yeah, so I'm just going to create application key here. So you will probably need a wallet, such as sub-wallet, or we have a MetaMask Snap support as well. So that's there as well. So if you want to do that, if you want to use that MetaMask Snap, you can use that as well. But I'm here using sub-wallet. So I'm clicking approve on that transaction, and yeah, and the application ID has been created. My application ID is 191, so I'll have to keep that safe. If I ever want to maybe query, if I forget my application ID but I know what my app key is, I just have to search for it with ETHGlobal Bangkok, and I'll get it later on. So if I search for ETHGlobal Bangkok, it should work if the internet works. But anyway, how do I deploy an Arbitrum Orbit chain? That's the main thing. So I have a Docker with me. I have my app ID. I have some Avail tokens. And I also need some Arbitrum Sepolia tokens because we'll be deploying a rollup on Arbitrum Sepolia, where Arbitrum Sepolia is going to be the kind of like the settlement layer, and we're going to deploy an L3 instead of an L2. So if you're building an L2, you just need the Sepolia tokens. In this case, we're doing L3 for actually quicker finality. But yeah. essentially what you have to do here is now you just have to pull our Avail Nitro node image. And once you do that, you also need to git clone the Avail Nitro contracts. So this means we already have our own modified versions of the Nitro contracts and the Arbitrum Nitro node. We just pull all of those items. We just change the environment variables. So if you actually go here, I can go to my code here. So yeah, wait a sec. All right, so yeah, so when you actually so when you're actually git cloning your Avail Nitro node, Nitro contracts, what you are going to do is you're going to check out at a particular branch. In this case, it's v2.10 upstream v2.10. You will see a sample environment.env file here. You basically have to fill these three things. What is a rollup creator address? It's a default factory contract address that will deploy all of the relevant smart contracts for you. That will deploy the rollup, right? So that's the first important thing. What is your rollup creator address? If you're going to be using Arbitrum Sepolia, you'll just copy this one. In case you want to probably use base Sepolia, so we have support for Arbitrum Sepolia and base Sepolia to deploy your rollups onto. So for base Sepolia, if you want to try using base Sepolia as your settlement layer, you can actually find the contracts down here in smart contract reference. So the rollup creator address for base Sepolia is also mentioned here. So you just have to replace with that. And once that is done, you have to put in an Orbiscan API key. You can get that from Orbiscan directly. And a DevNet private key. This is your EVM compatible wallet. So your MetaMask address, or you can use Foundry or anything else to actually create a wallet, right? And then put the private key into that, right? So that's there. Finally, everything else is optional here if you want to do anything else with it. Now, again, if you want to have a custom gas token, you can put in the address of that token, and by default you can now configure it. You configure your rollup to have that token or that ERC20 token to be your native gas token. So you have configured some of the stuff that you need to actually deploy your smart contracts. Now what you're going to do is you need to go to .script /config.ts file, and you have to basically add this bunch of JSON text. What essentially it means is that, if we can actually go here, so yeah, so in my config.ts, what I'm doing here is I'm trying to essentially define what my confirming period is going to be, what will be the challenge period be, also my chain ID, right? So this is where you define what your chain ID is going to be. You can obviously mess around with any of these parameters. For the hackathon, I suggest just keeping it as default, and if you want, just change the chain ID, because that's the simplest thing. Just keep it as default and just deploy your contracts. You can deploy your contracts by just running yarn builds for Joule. Yeah, sorry. You have to yarn build for Joule to compile the contracts, and then run deploy ETH rollup, and depending on whichever settlement layer you're using. So in this case, in the docs, we're using Arbitrum Sepolia. You can use base Sepolia as well, like I said, and then just deploy contracts. You'll see an output like this, which has a lot of the, all of the important contracts that are being created that will actually function as your rollup. So rollups essentially are smart contracts, and you'll get all of those contracts deployed for you. We already have a script set up for that, so that's great. So okay, you've actually deployed your rollup. Now you have to actually run your rollup. Now to do that, you need to have a node, and for that we use something called as Orbit setup script. Just clone it and create a node config.json file, meaning that if you go here, just create a node config.json file within the Orbit setup script, copy paste whatever's in here. You'll see that you'll need to kind of define some parameters, right? So essentially, if I can actually wrap my view here, yeah, so you'll see that I need to define my chain ID. Everything else here is probably already there. I'll need to define my chain ID here as well. My bridge contract address, my inbox contract address, my sequencer inbox, the validator utils. So all of this data, all of this address, what am I talking about? When you actually did, deploy ETH rollup using whatever network that you did, you got an output that is going to look similar to this. So you'll have all of the addresses that you need. You just need to input it into the node config JSON file, and also you will need to define the batch poster. So this is going to be an EVM wallet address. Even the staker is going to be an EVM wallet address. These two should be separate. Just change those as well. And just have an ARB, Sepolia, RPC. Just get the one from Alchemy or any node provider out there. Get an ARB, Sepolia, RPC, or if you're using Base, use Base, Sepolia, RPC. Enter your avail wallet seed phrase and the app ID that you actually generated before. And once that's done, you should be really close to deploying, like actually running your node. Again, now after you've done the node config file, you should also set up an Orbit setup script config JSON in the same folder. Again, you just have to do this. I know it's a bit tedious, but you just have to do it. It's just a bunch of copy pasting here and there because you already have all of that information. Again, you have to define the parent, chain ID, the name of the chain, all of the addresses of your, rollup. And once that's done, you change the Nitro image on Docker Compose. So on your Docker Compose file, you scroll down. Over here in the Nitro, initially it would be something from Off-Chain Labs. You just have to replace it with the Avail Nitro node. And once you do that, you can just run Docker Compose up and your chain will start running. So yeah, I mean, once you start running your chain, you'll have an RPC at port 8449. And if you just go directly to localhost, you'll have a Block Scout Explorer running as well. So actually, if I try and do, oh, sorry, wait 1 second. Yeah, I think my chain is already running. So let me try and go to localhost and see if it works. Hopefully that works. Yeah. So if you go to localhost, you see a local Arbitrum Explorer running. So this is the Explorer of your rollup that you just deployed. Yeah, I mean, so any transaction that you do, you can see it happening over here at the 8449 port. I mean, you can actually import it into MetaMask and maybe go to Remix and deploy a smart contract and test it out for yourself. What you'll see is that, the transactions happen really quickly. You'll see the transactions, happening in real time on the Explorer as well. So, I mean, that's pretty much it, right? So your RPC endpoint is going to be the 8449 port that you will be exposing from actually deploying your rollup or running the node, essentially. So yeah, that's pretty much it, actually. And then if you want to actually use your chain, you'll need to bridge some ETH from ARB Sepolia or Base Sepolia to your rollup. For that, we already have a script. You can just copy and paste this. Or else, you can directly go to the Arbitrum bridge, and they have an option to add a custom chain, and you can bridge it via the UI as well. But I just suggest by just using the script here, which will just do it for you. You just have to define your private key, the amount, and that's it. Yeah, and once you're done testing and you want to get your ARB Sepolia ETH or Base Sepolia ETH back, you just have to run this command and yeah, you'll get it back. So yeah, I mean, that's pretty much it. It's actually pretty easy. There's nothing much to do. There's no development effort you have to do. It's just a bunch of setup that you have to do. Like you have to deploy the contracts, the rollup contracts, and you have to just make sure that you configure the node to have those contracts set up. And that's pretty much it. And you can run your, rollup pretty easily, pretty quickly. Same thing with Cartesi. I can show you really quickly. Yeah, so for Cartesi also, it is pretty easy. In this case, you don't have to do a lot of the setup. What you have to do is you just have to install something called as Bruno, which is a node from the Cartesi team. And yeah, so based on your operating system, you can install the courtesy machine, install it, unzip it, and just make sure you add it to the path of your machine. And once you're done with that, yeah, you can just run courtesy machine and it will work. Now, how do you deploy it with Avail? Is you have to first install the courtesy CLI, and you can first test all of this locally. But if you want to use the Avail network, which is going to be more important for you in the hackathon, is that you can just run this command, which will do it all for you. So it will deploy your node, or it will start running your node. It is all integrated. You don't have to worry about anything here. You just have to install Brunodo. You have to install courtesy machine. And once you do that, you can just run Brunodo with Avail enabled and all of this information. But before you do that, you need to probably register your address. So you go to, it's already there in the repo. And if you want to find that repo, it is already in the price pool references section. So you just go here and you register your wallet because you will need that, and you will get your application address. You will have to input that into, oh yeah, okay, cool. Yeah, so you see a DAP address here. You just have to input whatever address you got from that. Once you register your address, you'll get a DAP address in return, and you just have to input that here. And once you do, you can use courtesy create my DAP in whatever template you want. It supports Python, Rust, Golang, JavaScript. So, and in this case, if you do that, you don't have to worry about actually running the rollup. Like you are running the rollup. It's just that you have to now, you just have to focus on actually building your application in any of these languages like Python, Rust, Golang, JavaScript, and yeah, it works. And anything on how to interact with your DApp is, already mentioned here. I know we might be a bit short on time, so I'm not gonna dive into all of it. But yeah, if you have any questions, please do ask. Yep. I mean, whatever data you're posting to Avail will be public. So before posting, you'll have to encrypt it. So yeah, it's a public blockchain. So anyone who runs a node can actually see the data behind it. Anyone can actually look at that data. So if you want to keep your data private, you'll have to encrypt it before submitting it to Avail. Yeah. Cool. Thank you.
Test.
Cool. Just as a reminder that
20
you
minutes.
wanna have some questions.
I have to cut it
You have to do
short.
it between your 20 minutes.
Right, yeah. I'm just not sure why this is not working.
I'll let you know when you have 5 minutes left.
Ma ne znam kako se ovo... Želim mirovati ekran jer bene. Tu ne... Hey guys, what's up?
So I'm Philip from Bioconomy. I'm head of engineering in Bioconomy. I want to show you what we offer for today. So first, I want to go from beginning. Bioconomy is having 10K prize pool split into two parts. I have compiled a GitHub repo which could be helpful for part one of Bioconomy offering, which is the modular execution environment which we can use to build chain abstracted apps. Part two, we only got some helpful resources here, which you can use to build applications for the other part of the prize pool using Bioconomy smart accounts, Nexus, smart sessions, and AI agents, which is very cool. I want to start from beginning, actually from the end result of what you could build with Bioconomy modular execution environment, just to give you an idea, and then we are going to go through the code a little bit, just so for you to see how easy it is to build a chain abstracted application using our stack. So this is the end result of the small demo application which I have built. This is the application that has been running from this repository, which you should take a look at if you want to build with us. So it's /Bioconomy/ETHGlobal-workshop. You literally can clone this repo and then build and run the project to get the same application which I'm showing you right now. What this application is doing, and I'm a Solidity developer, so don't mind this front end here. It's a very simple thing, but I just connected my MetaMask wallet, which is actually this one. And I got myself a generated smart account wallet address, which is generated behind the scenes, doesn't even have to be pre-deployed. And I can use this address using our SDK to build chain abstracted applications. So this example does a cross-chain minting, which means that we have one NFT application, which is deployed on base Sepolia chain, and it accepts USDC for the payment of minting NFTs. But me, here, I have USDC balance on another chain. I don't show it here, but my USDC balance is actually on Sepolia. So what I can do with Bioconomy modular execution environment, only on the front-end part, so zero smart contract development involved, I can build a flow that basically bridges funds to base Sepolia chain. If you also have to, you can swap funds and then interacts with any DeFi or NFT or any other smart contract. So all of these steps you define on the front end using our straightforward SDK, and you simply encode these transactions, very straightforward, developer friendly, while the users only have to sign once. They don't even have to have gas. They can see this cross-chain operation getting executed in front of them. I'm going to trigger the cross-chain mint operation right now, which is going to basically in this moment, the front end is defining steps that are supposed to be executed. The steps involve bridging USDC from my home chain, which is Sepolia, using a cross bridge to base Sepolia, where the NFT sits, and it's gonna use those funds then to mint an NFT. So as you can see here, I'm doing an off-chain signature with my MetaMask. This message here is the root super transaction hash. We call these like complex flows, we call them super transactions. You as a developer define them on the front end part, and what you get back from our SDK is one single root hash that the user has to sign, and they're gonna execute their operation. So right now, again, sorry for the front end part here, but I got back the super transaction hash result, which I can open in our Explorer, and I can look up for my transaction with this hash. So this is a many chain transaction, so we can see what's happening here. Basically, I paid for gas fees on Sepolia. That's one user op. Then I bridged funds from Sepolia to Base. That's another user op, which just got executed. And now we're waiting for the final user op to be executed, which is like the actual minting of an NFT. So all of this is happening behind the scenes. To the user, you can show just one spinner. You could get like also a feedback from our Explorer as the steps are getting executed. Basically like the best user experience you can ever imagine if you're building anything across multiple chains or multiple DeFi protocols within a single chain, or whatever like combination you can come up with. So we are still waiting for funds to arrive at base Sepolia, but as soon as they do, you are going to be able to see the effect of this transaction. Let me go back to this code base for a little bit before the transaction is executed, just to show you how easy it is to use our SDK. So this is like a React application which I have built, which basically contains the code to interact with this NFT contract across many chains. The core part of the process is you should just initialize our SDK using users EOA wallet. Let me show you that part. So this is abstract service. That's what I've called it. Is the service I'm going to call from my application whenever I want to interact across chains. It has this important function which is called init cluster service. Cluster is the old name of our modular execution environment SDK, which you are going to use in this example. We are using it here. So here we initialize cluster. We just give the cluster SDK user's EOA address, which is going to be behind this SDK, and then we can start building these cross-chain flows. For example, this function here, cross-chain mint, what it does is it defines bridging operation and minting operation by a very straightforward procedure. So it's just literally defining user ops and their call data. Very straightforward. If you've ever built a transaction, you know how to do this. Once we've defined the bridge and mint operation, we combine them together into what we call an ITX, or in a new terminology, a super transaction. Here we define steps that we want to see executed, which is bridge and mint in our case. But as I've said, you could put like 20 operations across 10 chains, whatever. And we also define the fee transaction. So what's the fee that the user is using to pay for this whole operation? As I've said, the user doesn't even have to have funds on their EOA. If they got any balance across their smart contracts, which are generated by Cluster, they can use those funds to pay for fees. And again, all of this is happening in just one signature. So once I have built an ITX object, I can literally just fetch the quote from the Cluster main instance. And once I get the quote back, I just have to sign once. So the part where I have been signing the off-chain message with my MetaMask, this is like that part of the code right here. Once I sign the message, which is just one off-chain signature, I literally call back cluster.execute again, and we are good to go. This is the part where I got back the result of the operation. The result of the operation was actually the super transaction hash, which basically is not a single chain transaction, it's many chains, so we have to use our own explorer so that we can show you what's happening behind the scenes. One important thing here is that you also should be using some of the bridges available today. Why? Because you need to see funds moving from one chain to another sometimes, and we are not the ones who are providing liquidity. We are just the layer that basically orchestrates transactions across many chains. But you're still going to have to use maybe a cross-chain messaging, depending on your use case, of course, or either a liquidity bridging solution. In our case, we are using a cross. But as I've said, like our stack is unopinionated, so you could use anything. We use a cross because it's fairly quick between different L2s, and we just have to like define a plugin for every bridge we want to use. This is my plugin for a cross bridge. You define this only once, or like if you guys are going to build something and you need a cross plugin, you could just copy paste it from here. This plugin has to be exposed to the Cluster SDK so that the Cluster SDK knows how to pull funds from many chains to execute the operation on the destination chain. Important part that I have not mentioned here is that Cluster SDK is the one who calculates some of these steps when it comes to bridging. Of course, you have to define what you want to do with the funds when they arrive on the destination chain, which is, in our case, is a mint operation. But actual bringing of funds to the destination chain is basically orchestrated by Cluster. You can see here that I have just called the encode bridging ops plugin, which we have here defined in our repo. And I just gave it a basic information. Okay, I'm working with USDC. I gave to this plugin something we call token mappings, which is like a list of the same tokens on every chain and their addresses. Like in this case, I have multi-chain USDC, which is a token mapping that defines the addresses of USDC deployments on different chains. So I say to this bridge plugin, I'm working with multi-chain USDC. This is my cluster account. This is how much I want to see landing on the destination chain. This is the bridge plugin, and basically this results here in series of steps that have to be executed to get the liquidity on the destination chain. Then we just combined this with the actual mint operation, because now we know we have at least 2 USDC available on the destination chain. We just bundled this together, and basically that's it. So what can happen here too with the liquidity bridging and encoding steps is that our SDK can figure out that you have liquidity across many chains. For example, you have 5 USDC on Polygon, 5 USDC on Optimism, and you need 10 USDC on Arbitrum. Our SDK is going to encode steps that pull from both chains. You don't have to take care about this as a developer. Let's go back to the actual Explorer. Yes, so now the second user op was executed too. We can go to actual user op Explorer to see what happened here. By the way, this Tenderly Debugger and User Op Explorer are very useful if you're going to build with this. You could debug your user ops, and because they can sometimes fail, of course. If I bridge 5 USDC, but I want to spend 10 USDC on the destination chain, of course, this second user op is going to fail because there's no funds available for my operation. Yeah, I can see here that I have successfully executed like the final minting transaction. We can copy paste the transaction hash and go to the actual base Polia Explorer to see what happened there. So this transaction has in fact paid for the NFT in USDC, and then it received the NFT to its smart account wallet. I could have changed some other operations in this process, maybe send some NFT somewhere else, or literally like anything that comes to your mind probably could be built using this approach. If it involves multiple DeFi protocols, multiple contracts which you need to call in one operation, or even across many chains. We support 8 mainnets and 4 testnets. I suggest using like cheap testnets because Sepolia is very expensive. I just had to pay like 18 USDC, so that's 1/8. For my transaction, that's because that was initial transaction, which also has to deploy a smart account. That's a lazy procedure that happens by default once the users interact with our stack for the first time. Okay, going back to the actual repo, here I have tried to explain on how to clone this repo, how to spin this project, which you have just seen in action. This is cross-chain minting of NFTs. And you could reproduce like the whole application. You could get it live and running. You could actually test the cross-chain minting stuff. I also got some useful information here on what your environment should look like if you are going to use the MEE or cluster SDK, which is the old name for our stack. And there's also some useful resources here. You're going to have to probably use USDC faucet. So USDC has an official, so that's by Circle, right? They have the official faucet that you could use to get some USDC funds on testnet. I have used this, for example, for today to obtain some USDC to test my flow. There is our full zero to hero guide, which explains step by step how to build an application using our chain abstraction stack. Then there is the Explorer, which I have just showed you. This is where you go to see what's happening between chains. Then you have the node info. This is something I haven't opened, but we are running our public node. So cluster or modular execution environment is actually a network of nodes which provide this service of executing transactions for you as a developer and for user who's using your app across many different chains. So here, of course, you could see like all the chains we support in the node info, and also all the tokens that are accepted by the node per every chain for gas payment. You could see that there's stablecoins here, wrapped Ether, and stuff like that. Finally, we do not have this exposed in our SDK yet, but you as a good developer would like to show to the user steps that are happening as they are executing in real time. So here I've put the direct link to our API of the Explorer that you could be using to fetch the details of one complex cross-chain action. So here we see how that looks like. You're going to figure it out very soon. It's just /explorer/super transaction hash. That's the hash that you receive back when the user actually executes the super transaction. And this is something that you could use to track the status of every user op as they're getting executed. See here, there's a list of user ops. It's always going to contain a status. Right now it's success with transaction hash, but this here could be pending for every user op initially, and then as the user ops are getting executed, you could be seeing different results here. You would have to poll this URL, right? Okay, back to repo again for one last thing. So this is half the price that we in Biconomy offer is for chain abstraction applications using this cluster SDK. And this is a good start here, this repo, so this ETHGlobal workshop. There is the part 2, which is another half of the price, goes to the actual Biconomy SDK, which you would use basically to create, for example, AI agents that interact with Biconomy smart accounts. And basically, there is a piece of the price for AI agents and piece of the price for usage of smart sessions, which is the latest thing we released in the world of smart accounts. A very powerful module which you could be using to build like cool applications powered by smart accounts. Finally, we will be offering developer support. This is our public group, Biconomy Builders Group, where you could just like reach out to us. We are not going to help you to build your application and win the prize, but we will help you if like you have like a huge console stack trace and a bunch of red lines. We might be able to help you with that, of course. You could just join using this link. This is a Telegram group, and we would be very willing to help you. Yes, that's it from me. We got 2 more minutes left. If there is any questions, I tried to spare 2 minutes, so let me know. Yeah? Can you just, yeah.
I saw that you made the user sign a blind hash. Is it possible to do that also with a more like with a type, for example, signature or not?
So it's always one root hash. With
Always a root.
It's always a root super transaction hash. So all the operations that are bundled inside a super transaction are described by this one hash that the user has to sign, and that's basically it. That's like one off-chain signature. You would be, for example, using a VM, which I was using in this repo, to just initiate like a signed message call on the user's EOA. And you would literally provide the VM with the sign message function with this root transaction hash, and that's it. Yeah. Anyone else? Yeah.
Can super transactions fail mid-flight?
If the transaction, what happens if the transactions fail in the process? Yeah. The UX gets impaired a little bit because, like, let's say you defined an operation that bridges 10 USDC to chain B from chain A, and then you try to on chain B you try to buy something for 20 USDC. This is a developer error because the user ops were not defined properly. So what's going to happen is 10 USDC is going to get bridged, but the destination chain operation is going to fail after some time. Our nodes are going to wait for some time to see if there is going to be any moment when the transaction is going to succeed. If not, they're just going to execute the transaction with status fail, which is what you are going to be able to get on our API for the Explorer. Yeah. All right, guys, thanks for listening. And I'm going to be at Biconomy's booth on that opposite side where all the booths are. If you want to ask me something, come stop by. Feel free to talk to me. Thanks, guys.
Two, test. Okay. Should I start? Okay. Hi, everyone. Thank you for being here. Chili's workshop. One sec. Yeah, so I'm going to start with the important things first. If you didn't get a chance to get a t-shirt at our booth, we're getting some more tomorrow. So you can come tomorrow in our booth and grab a t-shirt. So I'm Elias. I work for Chili's. I'm a product owner in the dApps team where we build actually decentralized apps, which is what people will do here at the hackathon. But we get to sleep. People here don't have time for that. So jokes aside, I have some devs with me today here. So Raul, Sagar, and our blockchain lead developer is here, Cyril, to answer any technical questions you may have. I'll say some few words about Chili's. We've been around for I would say over 6 years. But only recently, maybe a year ago, we became a layer 1 EVM compatible blockchain, and we specialize in sports and entertainment. So sports, fine, and entertainment. Why? Because we have huge partnerships with brands like Paris Saint-Germain, like Barcelona, like Juventus, and this is why we're looking for products on our chain that leverage these partnerships. We've created fan tokens with these partners, which are ERC20 tokens, and these tokens allow fans to engage with their team all over the world. So you can be a Barcelona fan in Thailand and engage with Barcelona. You don't need to be in actual Spain, in Barcelona, I mean. So having said that, and speaking of fan tokens, I'm going to go down to the first of the two categories we have for this hackathon. One is fan token utility, so giving utility to fan tokens. For example, retail-facing platforms which optimally utilize fan tokens for social, commerce, live event, or any other experience around that. We have 2 prizes there, almost 3K for first place and almost 2K for second place. And we also have a second category with 2 prizes again, where it's about building SportFi projects. So ticketing, marketplaces, prediction markets, sportsbook, anything like fantasy, walk to earn, move to earn kind of apps. So this is what we're looking for. And we have $1,000 extra that we'll be giving to the top project, or another project that really strikes out but is not in the winners. Maybe it has potential, but it doesn't make the cut for the winners, and we can award it there. So a total of, five prizes. Now, here I'm logged on docs.chili's.com, and that's a perfect place for developers to go to. We have a video that shows how to add our RPC and our mainnet or testnet networks, but also useful links. So, for example, our testnet is called Spicy. You can find out how to add it, what RPC to use, how to get test tokens. We have a faucet called Tatum that you can use, but if you need more, you just come to our booth, or you can message us on, what's the app called? On Telegram. I always mix it up with Discord. On Telegram. And we have a group called Build on Chili's, and you can ask for more tokens there. We'll be available, and we'll just send you tokens. You can find info on what is the minimum base gas free to use, gas limit, anything you want. We have documentation on our latest changes on the blockchain. Our partners, we have dev tools, what RPCs to connect. So like we have Morales, Statem, Web3, there's a list here. You can check out the documentation. And we also have resources like guides. We have a bridge in case you need to do something with a bridge, tools. And I also suggest, if you go in this documentation, to try out the quick start section. But if you just want to see what we've condensed here, you just go to docs.chili's.com, you go to community, and then you go to ETHGlobal Bangkok. And that's where you can find everything. Yes, yeah, and in the video, at the end, you actually have, you can see how to add our RPC and how to connect to our network, etc. So if you want like visuals, you can go there. And basically, that was it. If you have any questions. You need a mic, because I won't hear you with the DJ.
Is Chili a supported network on Farcaster like Frames? Can I build frames with Chili's?
Can we bridge frames to Chili's?
Yeah, frames. Webcast frames.
Serial? I don't think we support that. Can we bridge frames to Chili's? I don't think so. No.
Okay, so like if I want to do message passing, then which protocol can I use to connect with Chili? Like if I want to send a message from one chain to another, does layer 0 or like hyperlane support chilies or like any other messaging protocol?
Messaging protocol.
Yeah.
Because I have a DJ, so I'm not. So you can actually ask. He's next to you. Ask Cyril.
Okay,
So he can hear
okay.
you better.
Sure. Yeah. That's fine. Yeah.
You can come to our booth because the music is not as bad there, and we can discuss.
Sure. Thank you. Yeah.
You're welcome. Anybody else? Another question? Perfect. Thank you.
Yes, sir.
No, I'm kidding. It's very uncomfortable to speak to people. Sorry? Yeah, I'm with Elias.
Hey.
Hey.
Your chain is EVM compatible, is it?
Yeah.
Okay, awesome. Then we'll quickly make a documentation out of it.
Ba, 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 ba.
Hello, hello. Hello, how's it going? So let me quickly just start off the slideshow first of all. So this talk is all about Web3 Auth, how you can use Web3 Auth in your application and win up to $10,000 this weekend. So first of all, my first question is, how was your first dApp experience like? For me, it was not very intuitive, to be very honest. It was like I opened up MetaMask, I had to learn how to create a seed phrase, and I had to like download that extension and do all sorts of stuff just to access. I guess I was trying to see OpenSea and just trying to see what NFTs are like, and that was a pretty bad experience for me. So most of the people who start off with Web3 is like they have this kind of an experience, right? You have to enter an application. Oh. You can come in, please. Yeah. And they have to understand what is a Web3 wallet. They have to install a mobile extensions and all sorts of stuff. The same problem that I faced. And they just drop off because it's not a great user experience. People just want seamless logins that they have in Web2, right? So the Web3 experience should be as simple as how Web2 has figured it out. Just click Google login or whatever, and just start using the application, right? So it should not be complex. And the major reason because of this is people are not aware about handling their keys. They just lose their keys very often. And just a single factor it is, right? Seed phrase, if you lose it, if you have written it on a piece of paper, you're gone. If you write it on some Google Doc or something, you're hacked and you're gone. So even 3.6 million BTC is lost. Think about 100K BTC at this point, $36 million. Sorry, 3.6 billion dollars it is. So it's a lot of money that has been lost in this. So what users are familiar with? As I mentioned, just get into the application, one-click Google login, and start using the application. It can be Facebook, it can be email passwordless, it can be passkeys, these kind of things. And that is where Web3 Auth comes in to help this adoption particularly. So the major part of Web3 Auth is these seamless logins are done using a non-custodial management. Like if you're using Binance or some other application, you are technically not owning the account. The account is owned by Binance, and that's what happened with FTX and their hack as well. Not technically a hack, it was a scam, right? Because they took your money and went away. This cannot happen with a non-custodial key management service. And that is where Web3 Auth enables the same experience inside of your dApp in the same way what you might log in into Binance or somewhere else. So it is compatible with all the authentication methods. You can spin up your own, you can use Google, Auth0, Firebase, anything. And it is globally scalable as well. Everywhere you get the same high-speed networks and same logins. Basically, we can be totally hidden as well. So how this works, let's go through that. So when a person comes into your application, they trigger a simple login. We have demonstrated Auth0 over here. And the login provider like Google, Facebook, anything, they can be used instead of Auth0 as well. And they just provide the details. It's generally OAuth2, which means they will give you an ID token. This ID token is given to the Web3 Auth SDK, which in turn goes to our Auth network, which is powered by MPC. So what it means is your key is distributed into multiple parts across a node network, which is actually shown over here. So you can see there are 6 nodes. Technically, you need 6 nodes. There are multiple nodes hosted across the globe, and you need these to give you one part of the share. The other part of the share is stored in the user's device, or maybe a two-factor authentication like SMS, OTP, or authenticator and things like that. And it in turn gives you the private key or the signature, because the private key is always distributed. And these signatures can be used inside of the applications directly to make a transaction, as simple as that. So all of these things are happening, but the user won't even think about it. For the user, it's a one-click Google login, and that's it. And right now, we have 21 million plus monthly users using this all the time. And we support all the chains, and definitely the Ethereum ecosystem very, very special to us. And we support all the logins and all the platforms as well. You can use it everywhere. So I'm just demonstrating Web3 Auth really quickly. So I'm going to our documentation and I'm just trying out our demo really quick. So this is the Web3 Auth demo. And I'll just go and click on Google login. I hope this works because the internet is very bad. So, okay, this is working. I have clicked on Google login. And next, basically, after this, what happens here is, I'll get an account. You can see my account is displayed over here. I can copy my address. I open up a UI. I can see my NFTs or activity or whatever in this particular account. I can on-ramp things. I can literally do whatever I want in just a moment. And I can even mint an NFT and do all sorts of transactions without even knowing I am on the blockchain. So this is the special thing about Web3 Auth, that you won't even notice it's here and you will be able to do things. Thanks a lot for joining in. If you have any questions, just let me know about it. And let me go to the main thing, what you are here for, what you can do with Web3 Auth this weekend. So we are giving out prizes worth $10,000, and these are spread across all our different SDKs. So first thing, I'll go into our Web3 Auth plug-and-play SDK. This is what you notice over here in this demo. So basically, everything is built from us for you in our plug-and-play SDK. So one-click Google login, Facebook login, whatever, everything is built up. And if you just integrate this SDK, and obviously if you integrate more aspects of it, like custom authentication, I'll go to the documentation and show you. All the links are here, actually. So I can quick start. Inside of this, it's a basic application built, and you can just directly clone it in your local as well using this command, or you can just try out a preview right here, right? All of these things are made for you, and you can utilize this SDK in your application, and you don't have to configure a lot of things by default. If you configure something like custom authentication or add things like wallet UI, on-ramp, interoperability, it will be extra points for you for winning this prize. Next comes our mobile SDKs, right? So mobile SDKs we have under plug and play. You can just select Android, iOS, React Native, whatever. Or you can also go into single factor auth, which is a higher value price, particularly over here. And you can select React Native or any other SDK for that matter and utilize it. So a basic integration can be created easily using the quick starts. And if you want to deep dive into it, we have SDK references mentioned as well. So you can just directly go to the SDK reference, click on it, and just look at the different things this SDK has to provide to you, right? So it will be as simple as like just adding in the basic SDK and adding in all the features like wallet services we mentioned about it, wallet UI, and interoperability with Wallet Connect and things like that. And there's a very special thing about single factor auth is you can pre-generate the wallet before even the user logs in. So if you use that feature, we have mentioned it here, you'll get extra points for that. Next comes our single factor auth SDK in web. We were talking about all of these things on mobile. And in web, we have the same things you can try out. And you can even try out our passkey plugin. That is one of the major features we are trying to test as well as help you integrate over here. So the same thing, you can win up to $2,000. And you can just start off with a quick start. Or if you want to deep dive, you can go to the SDK reference and try out different things. Now comes a very special SDK we have recently revealed is our native account abstraction. So with a few lines of code right here, if you can see, I can easily enable, I have to go to React Native over here. So it's supported across React Native and the web SDKs, account abstraction SDK particularly. So you can easily abstract away all the different things, all the complex things about account abstraction. You can literally just define your particular smart contract provider, maybe Safe, Biconomy, and all of these. We have mentioned the particulars as well, Safe, Kernel, Biconomy, and Trust. And with a one simple bundler config, you can configure your smart contract wallet on top of Web3 Auth as well. You can also participate in the Biconomy prize and all other prizes directly through this. So if you use the native account abstraction from Web3 Auth, which all the links we have provided, and test out the whole flow in your application, how it works and stuff like that, let us know your experience and utilize it on Prod. We will be happy to give you up to $2,500 over here. And finally, mini apps. Telegram mini apps are on the hype right now. I can see multiple people already building it. And we have also introduced WorldCoin and Farcaster mini apps for this hackathon. So you can partner up with WorldCoin and Farcaster for their application and build a mini app on top of Web3 Auth to win this particular prize. We already have guides for client-side setup and server-side setup for Telegram mini apps. And the experience is quite smooth, actually. You just click on Telegram, open the mini app, and it will automatically log you in through the single-factor auth SDK what we have. So the guides are here. You can try it out. And you can just set up Web3 auth, basically. So if you build a Telegram mini app, you're not just qualified for this price. You're also qualified for the single-factor auth SDK price. If you build native account abstraction, you're not just qualified for this one. You're also qualified for single-factor auth and maybe plug and play or maybe mobile as well. So there are multiple combinations that you can do, and you can win a lot of prizes over here from Web3 Auth. And you can just simplify the whole onboarding experience. The main thing we are looking at is the UX of the application and how it works well and ties up with your whole application ecosystem that you have built. So that is the major thing we are thinking about, and we cannot see, we wait to see what are the things you have built over this weekend. So you can just scan this QR code. All the details I have mentioned will be over here. And you can connect with us. We are there at our booth, right literally in front of the entrance. You can just see our booth from there. And we are over here on the weekend. At least one of the team members will be present all the time. So just hit us up anytime. So that's all from my side. If you have any questions, happy to answer that. Thank you. Perfect. Okay, yeah. Okay, sure. So passkeys integration, I can actually show you a demo as well for that. You can just go here and look at the single factor auth. And if you see over here, if I have a passkey, okay, I have to unlock a few things to get my passkey. I don't have a passkey on this particular system. So I'll log in. I'll create a passkey right now. So I'm logging in using Google, and what happens over here is there's a simple passkey plugin. Let me open up the documentation and show you. Sorry. So this is particularly enabled by our single factor auth SDK. So if you just install this passkey plugin and just add this passkey plugin directly, you can easily integrate it. Literally copy paste this code and it should work. I'll deep dive into it if you want later on as well. But I can just quickly register a passkey right here itself. I think I have to unlock this. Just a moment. And I'll save a passkey right now. Actually, I want to select something else. Just a moment. Okay, so passkey is saved. And I can even save a passkey over here with my browser. And instantly, I can log in the next time using this passkey. So see, the passkey is right now saved. You can just see it popped up. And if I log out and I click on have a passkey and I sign in. Okay, sorry. Okay, I guess there are two different things conflicting with each other. I should have to remove this once. Okay, now this will work because basically what was happening is my system as well as OnePass were conflicting. As soon as I do that, one more is registered. It was detecting as iCloud, but basically OnePass was coming in. And now I log out. I can log in using this passkey right now. So yeah, it was as simple as that. So basically this will happen and you can utilize it inside of your application with like Basically 4 lines of code. That's what Web3 auth is all about. Everything 4 lines of code. So you can just quickly add this plugin. Just add your RP ID, means your whatever ID you're associating with it. So any email or any kind of unique user ID and your app name. That's it. So that you can just quickly add a username over here, and that's it. The RP ID basically is your app whatever.xyz, and username is basically your unique user ID. That's all you need to do, and click on login with the passkey. So that's how it'll work. Thanks. Any other questions? I guess not. So thanks a lot for attending it. And okay, you have another question, I see. Yeah.
Do passkeys work with React Native for you, for your platform?
So passkeys currently are supported only for browser. It's not supported for React Native. The single factor.js SDK works on the browser, and you can directly use it over there.
Okay, thank you.
Thanks a lot for attending. I'll see you guys later. Thank you.
Hello. There we go. Yeah, we'll just wait like 2 more minutes, see if anyone turns up. Feel free to ask questions throughout, because it's small, you know? I can hardly hear myself over this. Boom, 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 boom. We'll get started now, may as well. So, this is basically just an overview of NEAR to familiarize yourself with it. Our big push here is AI and chain abstraction, but I think it's really important to know the whole context of NEAR to implement an application to the best you can, really. And a bit about myself, I'm DevRel at NEAR. I came into the ecosystem building my own product and then started working as a DevRel just because I love the product so much and the company. So, yeah, today's goals. I'll talk a little bit about our bounties. The first is NEAR and AI. AI is the big push for NEAR at the moment. We want to be the blockchain ecosystem to build AI in. And as part of that, we're offering a 6K bounty to integrate AI and NEAR in whatever way you deem fit. And we'll get into more applications of that later. And then chain signatures, we'll also talk about more. This is signing transactions on other chains from NEAR itself. In this multi-chain chain abstraction narrative, but we'll get into these in a bit, and that's for 4K. So we'll give a bit of an overview of the whole stack as a whole, and I really want you to go away from this talk knowing how we can proceed together during the hackathon, like how you can get resources, how you can get help, because we want to support you as much as we can so you could build some cool stuff. So in general, why should you build in NEAR? I think the main point, the most obvious point, is it's fast and scalable. We're sharded by design, so the idea is that theoretically it's infinitely scalable and throughput will increase as it needs to. And we're also cheap. Transactions fees are going to cost you less than a cent. You don't have to really worry about gas costs. And we have user and dev-friendly experience with named accounts, access keys that no other blockchain system really implements, and things like built-in account abstraction and chain signatures. So, starting off, the account model. Really simply, NEAR offers named accounts. We also have these long strings of hex like AB256 whatever that you have to try and remember. Well, you're not going to remember it, but you have in your wallet and you have to copy the whole thing over. But the idea with NEAR is that my account is pivortex.near. You can send money to that easily because you can remember it, or you can just see it and type it out. And yeah, these are really nice to organize your applications. As you can see, I can have like my token listed under my app's bigger domain name, I suppose. And it makes it easier to deploy new accounts from contracts because you can have like factory contracts which deploy accounts for your users with either a contract uploaded to it or more specifics about the account. So I could have all my users listed under PyVortex if I wanted to. And we have, I suppose, native account abstraction, as in all accounts have smart contracts and all smart contracts are account. And that was since like day one when the protocol went live. And access keys. This is something that's not really known much about NEAR, but it's one of the coolest things. Well, to start off, we have your classic access keys, which is a key pair which can do anything with your account, control it fully, delete the account if you want. On Near, you can actually rotate these keys. So say I accidentally left my seed phrase in these slides, then if I was quick enough, I could change my key before you can access it, and I don't have to send all my assets somewhere else. But the most interesting thing about access keys is we have limited access keys, or sometimes called function call access keys, where I can create an access key that is only able to sign specific methods on specific contracts. And why you would do that is that we're actually going to give these out to applications so they can sign transactions on my behalf to make UX better, basically. So yeah, I don't know if you've seen this meme before, but it's the idea that this is the future of Web3 gaming, where every bullet you shoot, you have to sign the transaction in your wallet. Well, with Near, the idea is that this pop-up isn't happening because the app just signs the transaction for you. And yeah, these are limited access keys, but because these can call a function, the function can do more than the access key can do. So it can create an account or it can send Near. So they're not just limited to calling functions themselves. They can do what a function can do, obviously. So with that, you can like link drop people accounts with a function call access key. So I can allow you to interact with my app without you needing an account, essentially. Meta transactions. I don't know if you've heard about this, but we actually have meta transactions built in at the protocol level. There's no fancy workaround. It's just supported. Basically, how it works is if you want to pay for your user's gas, then you sign the transaction, whatever it may be, call some function on a contract, and it's then wrapped in a larger meta transaction and passed to a relayer who attaches the gas and the deposit to the meta transaction, and then that's sent to the network. And then when it's received by the network, it's like unwrapped, and the inner transaction is then processed as if it was sent by the original person. So you don't have to modify your app or anything. You just set up a relayer, and that's about it. Chain signatures. This is the thing I'm interested in the most about Near. And this is the idea that your Near account now becomes a multi-chain account, because you can derive all these addresses from your account. And this allows you to be able to sign transaction on like nearly whatever chain. It covers all Ethereum, all EVM, Bitcoin as well. And there's some partners here like Polygon, Arbitrum, and I'm sure a load of more EVMs. So you can hit their bounties by just signing your transaction from Near onto that target chain, which, I mean, you could probably do like 200 bounties here with this. So yeah, how does this work? Basically, you as a user wants to sign a transaction on Ethereum, so you create a transaction, and then you send that to the MPC contract, and then the MPC contract waits for an off-chain response from the MPC network, which sort of holds a sharded private key and then forms it together to create a signature. And then once you get that signature, you get it back to your contract and then back to the user, who then adds it to the transaction and can relay it as if you were just signing it with an Ethereum wallet. And these are the steps in more detail. So you have to derive a foreign address, and each Near account has basically unlimited foreign accounts because they can just change what the path is, like derivation path. Huh? Time? What is the time? We got 10. Ah. Sorry, I was a bit confused. But yeah, you derive an account, you create the transaction you want to send, you get a signature for that transaction, you put it together, and then you send it to the network. It's really quite simple. I don't know what that means. Some Spanish that I don't know, but the video is not working apparently. We'll just skip that. It was some video. I can show you a live demo if you want to see it. It was just basically how to sign a transaction in the front end. And yeah, when you put all these things I've talked about together, you get chain abstraction, which is you don't have to know about the intricacies of each chain. You just interact with blockchain as a whole, or even abstract an account and you're just interacting with this application, and it can be signing transactions and serving users wherever they are, and you don't really know about it. And one of the most interesting thing about chain signatures is that if we remember, a contract is an account itself, so a contract can actually call the MPC network and have derived addresses of its own, which enables a lot more use cases, and NEAR can essentially become this smart contract layer for other chains and have like a common interface, and you can do things like swap accounts. So I can swap your Arbitrum account for my Polygon account just with just inside of a NEAR contract, and that's done with NEAR's finality and NEAR's gas price, which is much lower than a lot of other chains. So I can send like Bitcoin or Ethereum without having to pay gas on that target chain. So what can you do with this? Well, I already said the first one really, but you can also create link drops on NEAR with an access key, like a function call access key that allows you to drop an asset on whatever chain you want to claim it on. You could do social login, account recovery, and things like very cheap multisigs is an interesting use case, because you can basically have one NEAR contract that controls like 1,000 different multisigs. So you don't actually have to deploy a multisig on Ethereum. You just have it like baked into a NEAR contract, and that cuts costs by a lot. Well, as well, DeFi on Bitcoin, pretty cool, but we're here at Ethereum, Bangkok, so it's better probably to do something related to Ethereum. Integrationless services. If you verify something on top of NEAR, then you can broadcast that to whatever chain you want. Like it might be cheaper to verify a proof or get an Oracle feed on NEAR, and then you can just send that to whatever chain you want with kind of little cost. So if you went to an event before, you'll realize that NEAR is the blockchain for AI. This is the big push. We want to become the ecosystem for AI, and it's not necessarily that we have integrations deep in the protocol level. That's not really what AI is about. We are making some changes with intents and stuff. But yeah, we're trying to build out an ecosystem that is just full of AI. And I think a lot of people have been saying that like data is the new oil as such, and we're trying to bring as much data onto NEAR and as much infrastructure and services, so it makes it easier for you to build your AI application here. Oh, I forgot I put this in. But this is basically all the AI partners inside of the ecosystem that makes it easier to build your app here. I think someone's taking a picture, so I'll wait. Yeah, take a picture quick if you want. 3, 2, oh good. And yeah, how can you think about AI in a hackathon with NEAR? Well, AI is the best place, NEAR is the best place to build with AI, because you're not just building an agent on top of NEAR, you're also building an agent everywhere since we have chain signatures. So why confine your agent just to one place? Why not have it be applied everywhere? So if you build it on Near, then you can serve everyone with your agent everywhere, essentially. And yeah, I spoke about the second point, but the account model really goes nicely with agent creation, since agents have given a bit more personality with their own named accounts, and they can act by themselves and live their own life as they want. And how could you use an LLM to make decisions on blockchain? So you can actually have a smart contract yield and resume, and it resumes based upon an external input, and that input being like a response from an LLM. So you can actually have a smart contract controlled by AI, essentially. And blockchain is pretty difficult to interact with, so how can we use blockchain? How can we use AI to make it easier to interact with? What can you build? Here's just some ideas. The first one is really quite cool, but quite simple. Basically, there was an application that was made before, a few months ago, where there exists a treasury full of meme coins, and what you have to do is you have to shill this smart contract and this AI model your own meme coin or some other meme coin, and the better you shill the meme coin, the more the treasury will rebalance its token holdings. So if you shill it well enough, then it will buy a load of your meme coins, which is just a fun little use case, but it really shows what you can do with a LLM inside of a smart contract. And next, indexers, they're kind of a pain to set up. So why can't I just say to some model, hey, build me an indexer that gets me this and this information? That would really make life easier. So if you can build some sort of infrastructure or service that is made so much easier by AI, that would be a great application. And like I said, with agents and named accounts, you could have an agent that acts autonomously inside of a blockchain's games economy. So it can go around buying skins or like weapons, items, whatever, as NFTs inside of this economy whilst no one is even online. So it makes the world and the game a little more like real life. And I'll just talk about some announcements that came recently that might be worth noting when you're thinking about building. Near just came out with, well, Near AI came out with an assistant, which it's like ChatGPT, but these models are very limited by, they can't perform actions for the user very well. So inside of this interface, you can let it control your Near account and sign and form transactions for you, and also generate interactive front ends inside of the model. So this might come in use when you're building. Take a look at that. There's also the research hub. So if you're interested in developing these models, we have a competition for people to build a model with it starting at like 0.5 trillion parameters, but then going up to 1.4 trillion. And there's like a competition to train these models in a decentralized manner, basically. And we have a new transaction type coming called Intents, which basically says, hey, I want to perform this action, but I don't know how to perform it. And then I can have some solver come in, which can be an AI agent, to complete that for me and finish the transaction. We also just had Ethereum wallet support, so you can plug in MetaMask to your application now on Near. So if you're coming from like a Solidity Ethereum background, you could just use the wallets that you're familiar with. And we also just had OmniBridge announced, which with chain signatures is very easy to sign transactions on other chains, but it's really quite difficult to get backwards. Well, OmniBridge is allowing you to verify state on other chains through like light clients, various message passing protocols. Yeah, cool stuff. And QR code time. If you're not in our group, I think most of you are, but scan this QR. We have links to our docs on there and also like a Telegram group. So if you can't find us about, then just ping me in there. I'm like the big orange muscly cat in that Telegram group. So if you want to talk privately, just ping me. And that's everything. I'm going to get some food now. Come talk to me in the queue if you have any questions. And thank you. Yes, shoot.